Good afternoon, everyone. I hope you had a good lunch break. It's already 2 p.m. and we are ready for our next sharing by Mr. Kelvin Goh. Some of you will be quite familiar with him if you attended the last workshop. Kelvin is from SAS, and this afternoon he'll be sharing with us on the essentials of situational awareness, supply chain analytics. Kelvin, please.
Thanks, Yong. Yong, can I just check if you can hear me?
Yes, I can, loud and clear.
Okay, very good. So I'm going to put the slides now. All right. Okay. If the slides are not up, please let me know. Otherwise, I'll get started soon.
It's good. Your slides are good. Thank you.
Awesome. Thanks. Thank you, everyone. Yeah, I hope that everyone have a good lunch. Back and then ready to discuss another topic that's really important in this whole series of workshop. So my name is Kelvin. I think some of you all have already heard from me earlier, in earlier sessions. So I will not go and spend too much time talking about what my company does or who I am. Okay, so my topic will be on situational awareness. Okay, and I'd like to introduce the concept of what is real-time visibility and collaborative decision-making. Okay, so a lot of the content that is going to be shown forward, okay, essentially is to facilitate conversations, is to see what are some of the reference models and also use cases in terms of how such technology stacks, right, comes together in order to serve a purpose. Okay, so in this series of workshop, myself and my colleague, we are given 4 opportunities to speak. Okay, so today, right now, I'll be covering situational awareness. And then in the second half, I'll also be spending some time to explain and also share essentially, right, okay, why is there a drive towards demand-driven supply chain? And what are the core components, right, okay, that will enable you a different setup as compared to a supply-driven kind of supply chain? Okay, so I'll spend some time to discuss that in the afternoon. If you all can spare the time and spend the time with me, I'll promise that there will be some good takeaways from this 2 sessions. The next thing that we'll be working on tomorrow will be together with my colleague Xiu Hui. We will be sharing essentially how do we actually use geospatial and also time and space as a concept to really perform analysis and also do the analytics, right, okay, that is possible using this sort of information layers. Okay, and lastly, right, okay, as a continuation from the last session I did on visualization and dashboarding, we also will discuss in terms of how do you actually design, deliver, and deploy dashboards. Also, some of the considerations pertaining to what could be some of the techniques that you could use, right, okay, in order to keep the dashboard always current, easy to work with, and then has got information, right, yeah, that matters. Okay, so this will be the 4 topics to be covering. I'll go straight into the topics right now. Okay, let me start with situational awareness. right? I couldn't help but to pull out a few pictures, right, okay, from the internet to kind of amplify the point about how important situational awareness is. Okay, I guess the first two pictures, right, with a bear at the back and also somebody with the bags getting stolen, right? Okay, I don't have to really explain what this picture is trying to say, but we need to be situationally aware, right? Okay, to always think that's happening around us. But let's run this little video at the bottom, okay, and then we'll take a look, right, as to what is this trying to say. Now, this is actually a project we did in Portugal, okay, and the concept is really very simple. Using the normal cameras, right, okay, we're essentially looking at this very important junction, okay, in order to see if any vehicles or people are on the railway track. Should there be a situation whereby the train is coming and then it is actually not clear in order to be able to perform the crossing, right, okay, safely. Now, this is an example, right, okay, of a feed that usually will go into a control tower or a command system, okay, and it's providing information, right, okay, pertaining to what is happening around us, okay. So with that, right, okay, I lead into really the definition of what is situational awareness, okay, and then from there, right, okay, let's understand what are the key characteristics, right, okay, to look out for. So as defined, situational awareness is really the perception of environmental elements. So this could be, for example, temperature. It could be what happens on different areas and space. Okay. It also has an element, right, okay, of events. We need to say what had happened. Okay, certain activities that's been performed by certain parties, and all this, right, okay, is in respect to time or space, or I might say both. Okay, so when you put this into a simpler way of looking at things, right, okay, is to be really aware of what is happening from time and space, okay, with all the information that's been picked up around you. Okay, the second characteristics, right, okay, is you must have the ability to comprehend their meaning. Okay, meaning to say, of course, here is when you do see something or you sense something yourself, you got to understand what does it mean for you. Okay. With that, right, okay, then of course you can actually go on to do certain actions, right, okay, as a subsequent of that observation. The third characteristics, right, okay, is now that you know what is happening and you understand what is happening, then of course you will do something about it. Okay. Henceforth, the third component, right, is the ability to really understand and project what could be a future status, okay, or future situation, right, okay, for you to really look into. Okay, so this, by definition, right, okay, is situational awareness. Okay, so when we understand this as a business concept or an operational concept, then you can start to form the picture as to what is necessary for me to be able to really grapple with the information and data that's coming through, make a decision to it, okay, with those information, and then you plan ahead. Later we will discuss more, right, okay, along the way. So according to Gartner, this is a report, right, okay, in 2018. Okay, up to 2018, the highest amount of investment, right, okay, in all supply chain initiatives still goes into the topic of visibility, traceability, track and trace, right, okay, in the entire supply chain. Okay, so this whole idea of being able to see, be aware, sense, is actually not as prevalent as how we would like it, okay, even up to today. Right, so this continues to stay as a major challenge for practitioners, okay, and for every stakeholders and players, right, okay, within the entire ecosystem. But why is that so? Okay, so let's take a look, right, okay, at first and foremost, what life would have been, right, okay, if let's say it is a well-connected and intelligent supply chain. Okay, so supply chain is a very long process, right? Okay, it's from anything from the management of the raw materials, the procurement process, the fulfillment, the transport, the warehousing, and finally, right, all the way to the end where you are delivering something to the final consumer, right, okay, or the final consignee, okay, of the goods itself. So if this is an ideal world, right, okay, a supply chain control tower should be able to look at everything from sourcing and procurement, okay, provide the visibility that cuts across, okay, you should be able to easily integrate the idea of track and trace, okay, so that information that's coming through your 3PLs is easy to be put together. It also aid you, right, okay, with your integrated business planning, IBP, okay, is because, right, okay, you'll be using, say, for example, your sales, your after sales, okay, the demand from the customer to be able to plan around a whole strategy, right, in terms of how to do, therefore, fulfillment. Okay, you also will be able to look into what is happening in the warehouses or the forward stocking locations. Now, over and beyond that, ideal world, right, okay, you should be able to have all this information and then do inventory planning, even looking into optimization, multi-echelon down. We need to say, right, okay, if it's a refrigerator, you won't be looking at it as a refrigerator, but you'll be looking at anything from the power cord to the spare parts to everything else, right? Okay, that are at the parts level. Okay. And finally, right, okay, you'll be able to use advanced technology to look into things like, for example, okay, using computer vision technology, look into defaults, faults, damages, so on and so forth. Okay, and then you'll be able to do very accurate demand forecasts. Okay, using various techniques. Now, this will be a great way to describe, right, okay, what a connected and intelligent supply chain could look like. Okay, but it's easier said than done. Okay. Before I go into describe, right, okay, what could be some of the possibility, I'm going to use a use case now of an airport scenario, right, okay, to kind of explain what really is a top end or top caliber sort of situational awareness. Okay. Now, first and foremost, right, okay, I bet all of us travel and also looking forward to traveling again. So all airports in the world, right, okay, all has got one similar characteristics. There are 4 imperatives, right, okay, that a complex environment that an airport looks to deliver, right? So first and foremost, right, okay, they are very interested in how they use their resources. They are always very mindful about the events and the situation that is happening within the airport. Okay, it is also looking to enhance the traveler experience so that they can spend more, use more, travel via that particular airport. And then because airport is a complex operating environment, so they also tend to look at cost. So airport is a very good example, right, okay, where a situational awareness is hugely important. But let's look at how complicated it is. Okay, so in an airport environment, right, okay, when we look at the main players there, okay, there are people who are working on the aeronautical side, meaning to say everything to do with the actual control tower operation, okay, and everything that happens on the aviation side. And then you have got the non-aeronautical side, right, okay, which is related to things like retail, building management, car park facilities, so on and so forth. And lastly, right, okay, on the passenger service side, okay, where you're also looking at things like, for example, all the cleaning of the aircrafts, the turning around the flight, the fuel, the baggage services, the cargo handling, so on and so forth. Now, all these are, of course, very closely related to us as logistic practitioners. Okay, but think about it from a slightly different angle. In order to have situational awareness in an airport operation, you have to combine the data sources, right, okay, of every single dimension that you see here in this circle, and at the same time, to be able to orchestrate the activities in such a way that a delay in one location does not create subsequent delay. A fire that breaks out, for example, right, okay, needs to be contained quickly, okay, so that all parties, right, stay safe. Okay, so there are many countless examples as to why an airport is actually one of the best examples to the idea of a control tower or having that situational awareness. Now, in fact, I think we all are familiar, right? Even the concept of logistic control tower actually came from the aviation space in the first place. Okay, and that's a fact, right? With that in mind, right, okay, I'm going to introduce the next level idea later as to why is it that airports are able to have situational awareness put together fairly easily. Okay, of course, it is complex. It is at the same time, right, okay, very challenging to be able to put all parties, all systems, and all data, right, okay, to be interchangeable. But there are ways, right, okay, as to how this can be done, and it takes a lot of effort, right, okay, from all these parties who are participating to get to where they are today. Okay, so I'm going to go into illustration as to what I'm trying to explain here. Now, situational awareness at airport is really a top imperative. It's simply because of the complexity of the operation. At the same time, right, okay, of the fact that everybody is operating within time pressure. Okay, now when the plane lands, it can't wait to turn around and take off again. So every single timestamp in the operation itself, right, is actually tracked because it actually has got a downstream effect on the rest of the operation if it doesn't move in synchrony with the rest of the operation. Okay, so because of this chain effect itself, it is usually a very tightly controlled maneuver. It's a very tightly controlled operation. Okay, not very dissimilar, right, okay, to say a military operation every day. Okay, so this screenshot here, right, okay, was actually done by one of my partners. Okay, and I'd like you all to take away a few big keywords, right, okay, that is over here. Now, first and foremost, in a situational awareness center, right, okay, or a what they call a airport operation control system, okay, now it's very typical that you will be able to have got some visibility to the space, right? So in this case, you could see is the runway is also looking into the space, right, okay, related to what kind of planes, what planes are coming in, so on and so forth. And then there's a concept of time. Now, the concept of time, right, okay, of course, is very important because it is going to be synchronized. It has to be operating, right, okay, in such a way that you do not create a stop flow challenge, okay, when people don't stick to time. And then there's a concept, right, okay, of the different environments. Okay, now whatever that you see on the runway is very different from what you see indoor. Okay, and at the same time, right, okay, all this information has to be layered on top of one another, okay, and be presented in different views so that different users and different persona will be able to see from their point of view what's important to them. Now, another very important word here, right, okay, is data. There is a lot of data that is going through this particular situation, this airport environment. Okay, anything, right, okay, from the travelers to the airplanes, to the cargo, to the luggages, so on and so forth. So data fusion, right, okay, is hugely important. Okay, and it boils down to this last word, schema. Now, in the airport world, right, one of the great things that happens there is because it is such a controlled activity itself. Okay, certain organizations will take on the imperatives to define the data definition or the data schema. Okay, and in this case, right, okay, it's something called AIDX, right? I won't bore you all with the details, but essentially it's the idea of a fabric layer so that every communication system is able to plug in seamlessly in order to create this unified integrated system that's able to provide that layer of visibility that all parties need to participate in. So all said, the most important word in my opinion here is actually the word schema. Okay, it's because in this case here, it actually takes some effort to really talk about the connecting fabric or the data fabric that is going to allow for subsequent communication. So this is something that we can learn from the airport environment. Okay, and then from there on, let me try to connect it to logistics itself. Okay, how do we look at logistics? Now, this is a very busy diagram, and it is deliberately kept busy, right? Okay, it's really to illustrate how complicated logistics, especially cross-border logistics, can be. Okay, when you look from the left to the right, and when you look across the entire stack itself, I guess the colleagues from E2 Open has made it very clear. It is very complicated. Okay, why is it complicated? Because there are a lot of players involved, from suppliers to the actual consignees, to the transport service providers, to the freight forwarders, to the brokers, to the actual ocean liners, right, and also the planes. Okay, so many parties involved. Okay, in order to see one shipment move from one location to another location is actually a complicated process. But what makes it even more complicated is because traditional logistics is designed to be forward moving. Okay, it's meant to move from the supplier to the consignee or to the recipient. Okay, so when you have got this process put in place and it gets delivered eventually, there is also a situation whereby you have to do the reverse. Okay, where you have got to do the reverse logistic part, right? Okay, say for example a recall, okay, or a return. Okay, these are examples of reverse logistics, right? Okay, that is also very complicated. So later we'll discuss, right? Okay, in terms of how that might apply for humanitarian logistics. But from an urban logistics angle, right? Okay, we all will recognize this is a complex process. Now, then we look into the different stakeholders itself. The physical flow, the trade flow, the finance flow, and the data information flow. Each of them has got its own imperatives, and each of them has got its own challenges. Okay, so if I might summarize, right, okay, in terms of the key capabilities that is being looked into, okay, and also the KPIs, right, okay, that people desire, okay, then you can see it actually mapped that. So all said, right, okay, this diagram here is saying that situational awareness in logistics is complicated, made more complicated because there are a lot of players and there are a lot of stages. Plus the fact that there's a lot of challenges and imperatives for different players within. So solutions like E2 Open earlier, right, okay, did give us a very good snapshot to how is it that a control tower can actually be put in place to solve some of those visibility challenges and also the situational awareness challenges. Okay, so let me go on. This report here is actually done by McKinsey not so long ago, a couple of years back. Okay, when it was actually talking about is there a role for advanced analytics and AI techniques? Okay, and if they do apply to the industry itself, okay, which are the industry that is most ripe for the picking in terms of their readiness to adopt such technology, okay, and where they need the most help? Okay, so you see, right, okay, right at the bottom, transport and logistics and travel are two of the areas that has got the lowest adoption of some of the more advanced techniques. Okay, and at the same time, right, okay, in terms of potential incremental value with AI and analytics, this is in fact, right, okay, the two industry, right, okay, that has got the most potential to look into. And I think it's easy to tell why. First and foremost, right, okay, when we saw the earlier diagram itself, is because the industry is fragmented and it is very complicated. Okay, so with the ability to work on a huge amount of data now, various type of data, and at the same time being able to pull everyone together, it actually offers an opportunity for the logistics sector to really transform and adopt some of these capabilities. Now I'm going to use the next few slides, right, okay, to go one step further to talk about how situational awareness can then be used, therefore, to aid in logistic operation. Okay, so of course, it's impossible to cover every single dimension and just for every possibilities. Okay, so I'm going to use a few examples to really illustrate how the technology can be put together and what kind of problems can it solve. Okay, so the use case I'm going to discuss now, right, okay, is a very specific scenario. Is assuming we're actually looking into cold chain monitoring and decisioning, right, okay, in terms of the transportation of vaccine. Now, I think the world definitely, right, okay, is looking for solutions like this and beyond. Okay, given the fact that we have got such a huge challenge, right, okay, going around the world right now. So I think it's appropriate. So please bear with me if, let's say, it sounds like something I heard before. Okay, but on the other hand, right, I'm going to use this example to really connect it back to logistics operation and how do we actually put all these things together in order to create a situational awareness I was trying to describe. Okay. Earlier, there was also a question from one of the participants pertaining to, there were a couple of questions, right, okay, pertaining to, besides just seeing, right, okay, in terms of description or in terms of static information, okay, is control tower, is it possible to use control tower to go one step further to look into prediction and also prescription? Okay, so this example I'm going to cite here, right, is going to bring up the flavor of both prediction and prescription as well. So it's really explaining how analytics comes to work, right, okay, in order to scenarios like this. Okay, so first and foremost, right, okay, let's understand, in terms of this particular example here, what we have done is essentially look at the types of data that's important in order to send a shipment of goods from a original point, a point of origin to its destination. So with that, the information that's captured in the first color here, the light blue font here, essentially is related to the package, right? It's related to the goods that is being delivered. Okay, so they're looking into things, information like, for example, the product ID, the quantity, okay, the number of dosages, okay, at the same time, right, okay, the origin and its destination. The next set of information that we're looking into is essentially the destination information. Now, by that, right, okay, is because this is a vaccine operation. Okay, we do have the information pertaining to the current stock level at every single clinic and also administration point of vaccine. We also have got information. We also have information pertaining to the current demand. Now, demand is because of the number of people who turn out to get vaccinated. Naturally, right, okay, once you have more people there, the number of stock will reduce. Okay. At the same time, we also look into some of the expectations, for example, the ETAs here, okay, the time and date that is required. Okay. We also have information pertaining to the product expiration, okay, the mean of the transport that is going to be used to deliver. Okay. And then we go one step further, right, okay, is to start to understand from a map layer, start to understand from the disposition of all the facilities and also all the assets itself, so that we are able to do some forward planning in terms of what could be all the possible routes, what are some of the alternate routes if there's a delay. Okay, at the same time, right, okay, if you need to do any kind of transloading plan, transshipment plan, okay, transloading plan in particular, okay, what other assets of transport is actually available, okay, especially not backup. So, of course, the list of data points, right, is usually longer than this, right, okay, but as a summary, right, okay, this is what was collected, because the problem statement that we're trying to work on here essentially is summarized here. Okay, when you follow the bottom of the screen here, what we're trying to do, right, okay, is to manage a highly complex distribution of network through continuous monitoring of all the environment control movements. Now, what that means, right, okay, essentially is I need to be situationally aware of my whole environment, of all my assets, of all the distribution point that I'm sending the vaccines to, and when the transportation is actually in flight, okay, in this case here, when the transport is actually moving, we want to know where it is. We want to know the geo position, right, okay, of the item. of the item in the truck that is moving in, the ID of the truck that is moving in. At the same time, right, okay, the more important thing is, should something happen, what can we do about it? Henceforth, what we are after here, right, okay, is to be situationally aware, constantly monitor what's going on, and we use a combination of rules and analytics to add in an element and dimension of alerts and then aid me with my decisions. Okay, so I took a while to explain this whole background is because it's going to give a very good illustration as to when you put all this together itself, how it actually looks like and how it can aid your operation. Okay. So now the situation here, right, okay, is this, right? We do have, in fact, a shipment of vaccine that's on this particular truck. Okay, it's actually moving, right, okay, from one point to the destination, an origin destination, okay, as per the routing plan, right? And among the rules that we have set inside, okay, is if the vaccine exceeds a temperature range of 45 degrees Fahrenheit itself, an alert will be triggered. Okay, now I can go on and talk more, right, okay, pertaining to what is advanced analytics way to work on temperature control, but that's not the topic today. Okay, so we'll skip that. But the scenario here is, first and foremost, there's an original movement plan. Secondly, right, okay, when this movement plan was put together, we already start to understand, should something happen itself, what are the rest of all the other possible centers that we can send this vaccine to. Okay. At the same time, right, okay, to complete the whole situational awareness picture itself, we also will look into every other locations, right, that we can send the vaccine to, should there be a situation. Okay, so this is at the back of our mind, right? We don't just know the origin and the destination, but we know the alternatives, and we know the full spectrum, right, okay, as to where else could have a possible use of the item, or the item, right, it could be shipped there. These are really all your coordination points, right, okay, from an operation concept, that is your coordination points. Okay, so now the situation, right, okay, that I'm going to describe, right, okay, is the following. So the temperature sensor within the truck itself actually did trigger an alert. Okay, and this alert, right, okay, through its computation itself is saying that there's in fact a temperature excursion. So this temperature excursion, right, okay, require a reaction in terms of what should I do next. Okay, what should I do next? So we now have got a situation whereby something really happened, but at the back of our mind, because we are situationally aware, we really more or less within the system itself have an idea as to what are the alternate locations we can go to. Okay, so the next thing therefore to do, right, okay, is to look into the kind of computation or the kind of fulfillment you are after. Okay, so let me explain further with the next slide. Now, in this design here, in order to look into the kind of different decisions that can be made once the alert is triggered, okay, we are after three different kind of optimization capabilities, or three different optimization models. Okay. The first optimization model, right, okay, is when something happened, we want to deliver the vaccine to the next center that is going to achieve maximum availability, meaning to say it will be sent to the center that is close by but has got the highest expectation of number of people coming by for injection. Henceforth, right, okay, you are able to expand the vaccine quickly, right? The second model, right, okay, that we're after here is to maintain the maximum potency of the vaccine. Now, by that, right, okay, what it means is because it does go through some sort of a decay process, okay, to be able to make sure that your temperature itself is compromised for the least amount of time and therefore doesn't risk compromising on the integrity of the vaccine. The second kind of model that we wanted, right, the second scenario that we wanted to score against is the idea of maintaining maximum vaccine potency. Okay, that's the second scenario. The third scenario, right, okay, is to achieve the least amount of waste. Okay, now when the vaccine, right, okay, is not planned properly in terms of consumption, what might happen is you could send a shipment of vaccine to one location and end up there is actually no demand. Okay, and then as a result, right, okay, you end up with the highest amount of waste for a very precious product at this point of time. So all said here, right, okay, what it's trying to emphasize is, now that I have a situation, I know what are the places that I can go to, I know all my alternate routing plan, I want to be able to use the system to compute and basically tell me, based on these three criteria, either highest maximum availability, highest vaccine potency, or by minimizing the waste itself, I want to decide where should I actually go to. Okay, so this is where an element of forward prediction has already been calculated, okay, in terms of where you can go to. The next thing here, okay, is by exploring it itself, we are going to prescribe a solution or prescribe an answer, okay, because of the models that we already put into the solution in the first place. So this slide is hard to read because it has got very little prints here, right? Okay, but I'll just describe to you all. Now, out of the three scenarios here, I pull two to demonstrate what is actually happening. Now, in this case here, the user, if you follow my cursor, the user actually chose, I want to go to the location that require the highest maximum availability, okay? So from there, right, okay, actually, based on all the different locations that it can be sent to, when we choose this particular criteria, it gets sent to this facility that's in this green dot. So you can see that the green highlight is actually referring to this particular green dot, and it's chosen based on the criteria of maximum availability. Secondly, right, okay, the second scenario here is when we choose a condition to minimize the wastage itself. Okay, in this case here, the destination is slightly different one. If you can compare the map here, okay, this is definitely not the same location as the one that is from the first slide. From the first diagram here. So essentially, what this demonstrated here is really a combination of, firstly, you have got a situational awareness as to what's happening around you from the movement of the vehicle to actually when a temperature excursion happens within the truck itself, it could be because the reefer has broken down. Okay. And from the alert itself, you decide, if that's the case, where can I go to? So using a combination of different criteria has been set forth itself, the system actually prescribed where this truck should go to, and henceforth end with a happy delivery, right, despite a situation that actually happened. Okay, so this use case here is a very clear-cut one, right? Okay, but actually combines the whole idea of the situational awareness, provide you with an idea as to what can you do as a reaction, and from there on, it also gives you the forward picture as to when this is executed itself, how will the picture be conclude to. Okay, so this is the first example I like to use, right, okay, to really illustrate in terms of what situational awareness and also some of the data analytics practices, right, okay, including some of the optimization techniques that could be involved in logistic operation. Okay, this will be a logical stop at this point of time. If there could be any questions, please read it out to me because I'm not looking at the chat. Or you can just unmute and then ask the question. Okay,
is there any question? Oh, wait, there is a question from the audience. Thomas, please.
Sorry, I always have so many questions.
That's great, actually.
Can you go back a few slides to the first slide about the use case?
This one?
This one, yes. Okay, so here you have a lot of inputs. You have different kinds of inputs, the light blue ones and the white ones. Okay, and then the other ones are outputs. Is that correct?
So you got cut off at the last part. So the inputs and the, sorry?
And the yellow bullet points are outputs.
Yes. Okay, it's also partly because we are also doing some sort of a geo-analytics, right? Okay, in the first place. Okay, so there could be some alternative, and at the same time, right? Okay, I also will not discount that sometimes we actually do dynamic calculation along the way.
Yeah, okay, I want to drive at something else. Your best route to destination, okay, I use that privately. I use Google Maps. Okay, using something like that.
Right.
Okay, and your example is in Raleigh, which I believe is in the Carolinas, somewhere beautiful roads, right? Let's move to ASEAN.
All right.
Yeah, ports or roads or whatever in the transportation infrastructure is interrupted. Now, how does your system then adapt to that? How can your system now calculate the best route? This goes, by the way, also to the mode of transportation. Can I reach the destination by pickup truck? Do I use a helicopter? Do I use drones? What is the availability of these vessels? of transportation?
Mhm. Yeah. Great question, right, Thomas? And you're right. So first and foremost, right, okay, the map layer here is definitely based out of the US. It's actually North Carolina. Okay, and that's where my headquarters is based at in Cary, North Carolina. Okay, and that's the reason why we have to use a scenario, right, okay, that is close to ourselves. Okay, because of a lot of the PII conversations, right? Okay, so we will never show those stuff. Okay, in terms of what we do for our own end customer. That's the first point. The second thing here, right, okay, is in terms of map layers, we are using anything that is generic. Okay, it is not unique to. We don't use anything that is proprietary. Okay, so in this case here, it could be an S3 map, it could be a Google map, it could be a one map, right, of Singapore. Okay, so on and so forth, or it could be Atlas King, whatever, right? Okay, so in that sense, right, from a map layer angle itself, it is non-proprietary and it's not unique to us. The next thing here, right, okay, is the idea of map layers, right, okay, and information layers. Because we all do know that when we talk about some of the geospatial analysis technique itself, you don't just look at the base map, but it's going to be layered, right, okay, with other information pertaining to, for example, road network access in terms of how they carry, how much they can carry, what's the laden rate, okay, what kind of road type it could be. Likewise, it could be infrastructure, okay, where the bridges, where the drainages, so on and so forth. Okay. So the designer, in terms of whoever that is going to work on this, right, okay, will have to look at it from what is relevant in terms of their context, and they'll put the necessary layers on top, so they're able to do other kind of fancy or nifty calculation, right, okay, like you said. Okay. So for example, if we are talking about an urban logistics scenario whereby we're looking into e-commerce fulfillment. Okay, now in those cases, right, okay, a lot of my topography map, right, okay, might not be as important as compared to the urban logistic kind of map layers. Okay, and likewise, right, okay, if we're looking into, say, a military or vice versa, right, okay, or humanitarian logistics on operation, then we probably will be looking for information pertaining to things like populace, the topography, okay, the existing road network, and more importantly, is to include additional information sources that could be non-static in nature. Say, for example, social information. Okay, social media information is a very precious resource that we use in operations like this. Okay, so that you are able to also stitch the picture together on top of whatever that's static. Okay, so tomorrow when my colleague and I discuss about geospatial and time analysis itself, we'll go one step further, right, okay, to talk about some of these pointers, because you are totally right about one thing, right? US maps are very easy to work with. Okay, other country maps, right, okay, not so. Okay, so we'll also share some of the practical examples and also consideration in terms of working with a different kind of data that is actually unique to different regions and also the different kind of operating scenarios. The last point, right, okay, pertaining to what you said about, if let's say I got to do multimodal calculation, okay, now what will I do? Now, I think it was cited just now earlier, right, okay, as a great example of the oxygen cylinder, okay, and also other kind of equipment, PPEs that is used for relief effort today. Now, the fact of the matter is, you will always account for all your logistic and transportation assets if you are planning to do a multimodal operation. Okay, so certain things, right, okay, are just not suitable to fly, and certain things are just not suitable to sail. Okay, depending on the criticality and also the urgency. Okay, so what we will say is, in terms of information itself, we need the data to be able to do the postulation. If the data is not there, we try to stitch out the picture by also doing other kind of activities like crowd source, not cloud, crowd source. Okay, so that you are able to get a situational awareness as intact as possible in order for you to perform analysis and then the execution. Okay, may not be the best answer, but that will be the answer that I'll master to you, sir. Okay, in terms of how we actually look into such problems.
Okay, thank you very much.
Okay, Calvin, you may want to take a pause there. We have a couple of interesting questions from the audience. Ismail has two questions. May I ask Ismail to articulate a little bit? Ismail, over to you, please.
Hello, hi.
Hello.
Yeah, hi. Okay. My question here is in the context of supply chains management, how examine can be used to leverage situation of awareness? That is the first question. And a second question is how to propose the model has been implemented in a software framework and how to conduct evaluation tests to examine situation detection capabilities. And the first question is the awareness, and second is the how to detect the capabilities.
Okay. Now, let me go to the second question first, right? Okay. Now, second question, right? Okay, is really about sensing. Right? Okay. It is when everything is a happy flow, right? Okay. Now, honestly, even if you have got no control system, right? Okay, a happy flow is happy flow, then that would be great. But things will never be happy flow, right? Okay, they always tends to be disrupted. That's why you put investment into whether situation awareness or some sort of control tower. The way to do sensing, right? Okay, can come in multifold. Now, in the second half of the session, in the later half of the afternoon, I'll be touching on demand sensing, demand driven, and also demand awareness. Okay, so these are actually fairly, if for lack of a better word, right? Okay, these are very interesting topics because it shows a very different way of looking at supply chain problems. Okay, and I'll ask that you follow the conversation later, where I'll introduce some of those pointers, right, pertaining to demand sensing, and also when going back to the point about knowing what to do. I'll give a real example, right, okay, of to this point itself in terms of what happens in the supply chain world, okay, when events hit. Now, I myself, I'm a supply chain practitioner, right, okay, so I do have got situations like this, right, okay, in the past. Now, a few that comes into mind, right, okay, over the last few years, okay, one of them, right, okay, you might remember was the Icelandic volcanic ash cloud situation, okay, that was one. The Japan earthquake, right, okay, that created a tsunami, right, okay, is another one. The other big earthquake, right, okay, that created a major disruption that hit our Southeast Asia region, right, okay, I think that one also very close to heart, okay. Now, when we look at disaster events like this, or man-made events, right, like for example, trade war itself, the number one question has always been for supply chain practitioners is how do I actually respond to it as quickly as possible? So while it's one hand trying to imagine that you have a perfect world whereby all this information will be collected, synthesized, and therefore, right, okay, I'm able to trigger my supply chain next course of action, I think you can do it. You can plan many scenarios, and this is where scenario planning and people actually do work on this kind of drawer plans. But there's another thing, right, okay, that is important, right, okay, is the idea of, after that, how do I actually automatically trigger some of the processes so that even if I'm sleeping, right, okay, I know that the next call for action can be taken when a situation that is in my drawer plan actually happens. Okay, so case in point, right, okay, some years ago when I was working in IBM, okay, I was ex-IBM myself, we were very concerned about, of course, our chips, right, okay, getting disrupted, especially for some of the very critical production in terms of mainframes and also what we call system Ps. Okay, so one of the design principle and consideration we had then is when you look into the material level itself and you understand that some of this material are extremely critical, you always work out a material planning plan so that you know where are all your alternates. Okay, so your alternate suppliers, alternate parts that can be executed. Okay, and you also contain and make visible for yourself all the time in terms of all these critical elements itself, where they are and what is the stock keeping inventory level at that point of time. The last thing that is always done, right, okay, is you put in an automation plan so that when something happens itself, regardless of human intervention itself or not, you just trigger the order or you'll just trigger the process first. Okay, so as supply chain analysts and practitioner come together, these are the kind of situations, right, okay, that you want to use. You use a storyboard to really go through the scenario, and then you work out your planning, okay, as to when situation happens itself, what kind of reaction will you do? And the reaction, right, okay, should take away as much as possible the human intervention part, because some of this situation simply does not give you the benefit of time. Okay, so the IBM example that I cited, right, okay, end up we were not disrupted at all despite the flood in Thailand and also the earthquake in Japan. Okay, it's because of that auto trigger mechanism, right, okay, that was put in place. And in supply chain operation, right, okay, one of the simplest example of that being put to work is auto replenishment or auto tuning, right, okay, based on the requirement. Okay, so as practitioners, right, okay, this is where you really have to combine a few different techniques and a few considerations together, and nothing beats having to do with that rigor, right, okay, or scenario planning, okay, so that you constantly stay ahead, right, okay, in terms of activities. So with that in mind, right, okay, then you go back to the point about situational awareness. So most really good world-class supply chain control tower in the world, okay, the minimum they will do, right, okay, is first and foremost this concept called monitoring or remote monitoring. Okay, more often than not, right, okay, they will put in different ways to really look at the whole disposition of all their assets or their equipment. So case in point, right, okay, let me cite examples of, say, be you are Lockheed Martin or you are in the case of Kone Cranes. Now, these are two of the customers that I can reference publicly. Okay, so what we do with them, right, okay, is in the case of Lockheed Martin itself, because they are supporting military operations, we do work with them, right, okay, to create this situational awareness capability so that all the different situations that can possibly happen that might compromise on the ability to support an operation is accounted for. And from there on, you develop your demand plan and you develop also your supply plan. Likewise, right, okay, in the case of Kone Crane, okay, that's got crane operations around the world, they actually use the concept of remote monitoring, right, okay, to really understand what's happening on the ground. Okay, so in that case, right, okay, is related to maintenance, because what they want to do, right, okay, is to make sure that when something breaks down, for example, even before it does break down, their engineers has already been activated along with the spare parts, and all they care about at that point of time, right, okay, is when can the customer give them a time so that they can perform maintenance. So these are the various kind of concepts, right, okay, that you see put in place when you really look at using situational awareness to then develop the next course of action in order to really not compromise or you optimize your operation. I hope that kind of helps to answer in terms of how it can be used. Okay, but of course, right, okay, it really depends on the context that you're operating in, the function that you're in, so forth. I hope that is useful as a response, Ismail.
Thank you, Mr. Calvin.
Okay, we have one more question from Krishna. Krishna, would you like to ask a question to Calvin? Krishna, can you hear us? Or maybe I can read it. I can read it for you, Calvin. Krishna is wondering how much your team invests for creating this system, actually.
Oh, okay. My personal opinion, okay, just now I already mentioned in the earlier presentation, right, okay, that situational awareness or control tower or operation control system or intelligent operation centers, right, okay, there are actually different iterations, right, okay, that parties can go into. Okay, when we talk about this sort of situational center or awareness, right, okay, it can actually be a combination of both technology and actually just reorganizing your workforce. Okay, so I've seen very primitive form, right, okay, whereby the concept starts with co-location. It's just people staring into their own screen and they are co-located. And then the next logical step, right, okay, is usually to put a overarching layer so that all the information gets pumped into it to create a common view. Okay, that's a second kind of situation or monitoring capability, right, okay, that people go into. Okay, where they actually put everything so that everything stays on one common layer, and from there, right, everybody has got a common view. Okay, so that is the starting form of an integration. Beyond that, right, okay, is where you go into other kind of possibility in terms of prediction or even intelligent decision making. So all said, right, okay, it means depending on the nature of the operation that you are after, and also depends on the kind of systems, how suitable they are, right, okay, to be connecting stuff together. Based on modern techniques, right, okay, in terms of the use of microservices, APIs, cloud technology, okay, by my estimate, right, okay, you can actually do some of the base capability, right, okay, in the matter of 3 to 6 months, okay, quite effectively, right. So this is where I was emphasizing in the earlier point, right, okay. In the past, it used to be very complicated because every system, right, okay, is written in different languages, has got its own databases, okay, and henceforth it's very hard to integrate them. And that's why the big system integrators around the world, right, okay, has got a lot of work to do, right? Because they have to put all these things together for you. Okay, but the fact of the matter right now, right, okay, is when we look at things from a platform angle, there are a lot of options already available out there. Okay, so they took away a lot of complexity in dot integration. And once you have taken away the complexity of this integration, the more important work, therefore, goes into pulling in the data, and then from there you start to do the kind of dashboarding and also analysis that you're after. Okay, so I would say, right, compared to in the past when a system like this, right, it could take 18 months, 24 months, or even longer. Okay, I think I'm more inclined to say that the first iteration, right, it could be out within, say, 4 to 6 months period. Okay, but of course subjected to really how complex things could be or it's not, right? Okay, if it's going to be, especially greenfield implementation, start from scratch, right? Okay, actually it's really not that difficult. Okay, I think in the interest of time, let me go on with the rest of the materials first before there's more questions, all right? All right. So I'm going to jump a little bit here, right? Okay, is exactly to answer to some of those questions in terms of what the audience, right, is really asking. So this picture here, right, okay, is when we're looking at this whole use case of vaccine distribution, just as with any other scenarios, right, okay, there's actually a process of putting the pieces together in order to be able to do some of those actions that I was describing. Okay, so this is actually a very useful chart, right, okay, for all members of the audience, right, okay, because I think it addresses regardless what stage of maturity you could be at. Okay, even if you are doing nothing, or right now you could be very advanced. Okay, this material here, right, okay, will still be relevant. So let me put it in context, right, okay, is in terms of the value versus the amount of time needed, right, okay, these are the axes that you see here. The fact of the matter here, right, okay, is to be able to do what I described earlier, you actually will go through a process. Okay, so it could be a case of initially, right, okay, we put some of the initial data points together so that we create a base status, okay, or this is really a kind of like a common dashboard of some sort. After you transform some of your static or some of those non-digitized information or systems, try to put it together, right? That's the starting point, right? The next logical thing, right, okay, is once you have accounted and start to imagine what is it that you're after, the next natural thing to do, right, okay, is to digitize what you have not digitized and then also attempt to connect them together. So again, right, okay, to my point earlier that in the past it used to be you have to work with XML and EDI and all that stuff, right, okay. The fact of the matter right now, right, okay, is a lot of times a lot simpler, okay, because data management capability, right, okay, and working on data fabrics, right, okay, has actually jumped a lot, leap and bound forward, right, okay, over the last 5 years, okay. So then there's this. So this is the second natural process, right, is you digitize and then you attempt to connect. The third thing, right, okay, that we normally do, right, okay, you start to try to configure some kind of rules to provide you with certain sort of an alert. So the example, right, okay, of temperature earlier is when you have got a range. You might remember I mentioned that the range that we're looking at, right, okay, is actually 46 degrees Fahrenheit. Now this is just a trigger. Now to me, right, okay, an intelligent alert is not particularly advanced. In fact, it is not advanced. Okay, and I would say that, well, it's a good first step. It is not what anyone should aim for. The correct thing to aim for, right, okay, should be the prediction before the alerts get triggered. Meaning to say, right, okay, the idea here is instead of risking the item being compromised and then you get an alert, you should know that the item is already going to be compromised in advance because you're looking at the patterns and the trends, okay, and then you stop it from happening, okay. So therefore, the next logical step beyond alerts itself, right, okay, is the idea of decisioning. Okay, it's the work with the ability of prediction and prescription to tell you exactly what are the options you have on hand, or to the point, right, okay, where you can actually look into the optimization. Okay, when you look into the automation, not optimization, but automation. The last thing here, right, okay, is when you look at a flow like this, right, okay, it does look quite linear, move in sequence, and it's quite simple. The real complexity, right, okay, is when you have got many dimensions, many items, many people, okay, and you are actually looking at supply chain, right, okay, as a process that's got a lot of stages, has got a lot of stakeholders, and it goes into different layers. That's why I think in the supply chain world, right, okay, at least from the commercial space, we always look at the supply chain operating reference model as a way to understand the complexity. So likewise here, right, okay, the ultimate level, right, okay, is when you're able to manage those kind of complexity. Okay, so later when I talk about the demand-driven and demand sensing part, right, okay, I'll be introducing concept, like for example, some of the advanced forecasting ability and optimization capability. So bear with me, and then I'll address more, okay, when I go into the afternoon session, the second half of the session. Okay, but this is the process, right, okay, where any organizations or any party, right, okay, could be referencing to, and it really starts from doing what you can do to aiming something higher, right, okay, where you can really aim to be best of class. Okay, but I would then say that it is possible to leapfrog right away all the way to the end, because there's just a natural sequence, right, as to what you need to go through before you really know as to what might mean the most to you. Okay, sometimes it could be over engineering as well, and you put in things that you don't need. Okay, so this is actually a good reference model, right, okay, to really develop this step-by-step guide. Now, I'm going to touch on in the next few slides, right, okay, to one engagement, which will give you all further flavors, right, as to what could be the step-by-step approach to creating situational awareness in logistics and supply chain using non-platform approach. Okay, non-platform approach, just a case of just knowing what you need to know. Okay, and from there on, how do you make decisions with it? So bear with me, I'm going to touch on that shortly. Okay. So that's it, right? Okay, I would like to kind of just introduce the whole idea here is, therefore, if you're talking about wanting to have a enterprise class capability, okay, this could be the picture, right? I'm not selling you anything here. I'm not trying to tell you that this is the picture you should aim for. But from a functional angle, I would definitely advocate, right, okay, that we look at the ability to work with different sources of data, okay, and then you are able to take in those information so that you know what your demand is going to look like, and henceforth you are able to plan for the supply that needs to fulfill the demand, right? So from a technology angle, right, okay, the other things to always account for, right, okay, is you got to look into the schemas. Remember, I was talking about data models and also some of the integration consideration, okay, and also the idea of how do you actually work on anything from data governance to data quality. Okay, so the data thing is not going to run away. It's actually the most important layer before we can perform any of the more fanciful analytics and also work that's related to this field. Now, you have all these pieces together, right? Okay, or somewhat, you have got a plan to how to get all this together. This is where you can really do your supply chain analytics. Okay, so supply chain analytics, right? Okay, can be represented with many big words, right? Okay, so for example, we talk about concept like multi-echelon optimization. What the hell is this, man? Okay, now this is actually talking about, because you have got a product that needs to be stripped down to the assembly layer, the parts layer. So a product, right, okay, is not available unless the rest of the pieces are all available. Only then you can see to the production process. Henceforth, right, okay, big words like this, right, okay, is what sometimes people throw at us. Okay, but the fact of the matter, what it's trying to say here is you get your data layer in place, then you can start to look into some of the analysis, and then you can do some of the fancy things, right, like for example, scenario planning. You can look into multi-echelon, or in this case, it's multi-layer optimization, so on and so forth. Right? And beyond that, right, okay, there's still one more layer. Okay, that's where you can also go into concepts like, for example, automated routing and scheduling, okay, end-to-end simulations, okay, so on and so forth. Now, the question here, right, okay, is this theoretical or is this done before? Okay, and my response, right, okay, is it's been done before. Okay, and it will continue to be done, right, okay, in at least pieces, right, okay, by organizations that we work with. Okay, so some of the most advanced player in this field that essentially has adopted just for every pieces, right, okay, will be some of the major customers, the likes of DHL, FedEx, and UPS. Okay, these are all the parties, right, okay, that we work with that actually go into this kind of work. Okay. Now, let's say, right, okay, this is an ideal world, right, okay, where you are able to have one single platform, you do everything. Okay, but is this the only way to do it? The answer is no. Okay, now I would say that this particular approach, right, okay, is when you have got a very large enterprise that you need to have really the best of class tools because your environment is so complex. The other approach, right, okay, is more of a bootstrapping approach, right, okay, it's really to look at what is it that you have, what is it that you need. So the next few slides, I'm going to cite an example of actually a master's thesis, right, okay, that I help as an industry supervisor. Okay, so it's actually worked by the student, right, it's not for myself. But I want to illustrate, right, okay, in that example, in terms of her scenario was a logistics company that cannot afford to invest in the best of the technology the world can afford. Okay, So she's given a task, right, okay, in terms of how do we put that together using what is at her disposal. So let's look at that the next case, right, okay, where we talk about building it up when you're not putting your money, right, okay, into a very expensive service provider like SaaS. Okay. Now, in this case here, right, okay, the way they approach it, right, okay, or as far as this discussion paper is concerned, okay, the first thing is we're trying to understand in terms of the performance of all the freight forwarders itself. Okay, the data that they provide, right, okay, tends to be fairly messy, tends to be fairly lousy. Okay, to the point, the estimated time of arrival and other kind of important timestamps are often reported, but far from accurate. Okay. Now, the logistic world, right, okay, is very common. It's extremely common, and I say this as a practitioner myself, right, that certain goods could have already arrived at the dock or at the port, and nobody knows. Okay. There could also be cases, right, okay, where the timestamp tells you that the item has already departed from Hamburg, when in fact, right, okay, it has been rerouted to somewhere else. Okay, so all these things can happen, right? And why is that so? It's because freight forwarders, for a start, right, okay, tends to take information that are third party. Okay, so it's second-hand information that comes from somewhere else. It's not their own, and henceforth, right, okay, the information tends not to be very accurate. So with that in mind, right, okay, the first challenge here is how do we put it together? Okay, that's a starting point. So it gets started, right, okay, by understanding from a workflow angle itself, who are all my key participants, who are all my ecosystem partners, and I start to investigate, right, into what kind of information can I actually get out of them, okay, in order to be able to create that situational picture a bit better. So the next thing here, right, okay, is the idea here is there is actually a lot of information on the web. Okay, there are a lot of third parties that you can subscribe to that provide you with good information, sometimes better than what your 3PL provide you. Okay. At the same time, right, okay, there's also other kind of public information related to, say, for example, weather information, for example, flight information, for example, other kind of meteorology information, right, okay, that is also publicly available. Okay, so the next thing here, right, okay, is to understand if my key objective is to really understand the on-target delivery versus the estimated time of delivery versus the actual, okay, I need to compare them, right, okay, so that I know whether I'm actually performing the task based on what is expected of me. Okay, so this particular paper, right, okay, actually goes on to discuss one more step, right, okay, which is understand what are the publicly available information so that I can do this computation first between the target, estimated, and actual. So, sorry, I forgot to mention, right, okay, so after this was put across as an initial postulation, right, okay, this student, right, okay, actually went on to do exactly what we planned to do, okay. And as it turned out, right, okay, there is actually a lot of information, for example, in the case of airlines and airports, you can actually collect a lot of the flight information, okay, and at the same time, right, okay, when you know what is your shipping air review, for example, okay, those that comes up from the shipper itself, you're able to stitch the picture on your own, even without going on to third-party service provider, right, okay, you're actually able to put in the information, okay, and then estimate the arrival time. So what we did, right, okay, was we actually took the information of Lufthansa, okay, by subscribing to via an API to all the information that Lufthansa was throwing out into the flight schedule, and by identifying which of the plane the cargo is going to be on, okay, using the arrival time, right, okay, that's published by Lufthansa, this student actually demonstrated that she was able to predict and then compare the results just by putting public information together, right, okay, as to serving the objective of understanding ETA, ATA, and the on-target ones. All right. On top of that, right, okay, is also she studied into the idea of now what else, right? Okay, now that I've proven that just using public information, using freewares, right, okay, I can actually run certain API script, put the information in. But this is not sustainable because this is a very rudimentary approach itself. Although it serves its purpose, the question is what else? Okay, what can I do, right, okay, to make it operationalized for her company? Okay, so she went on, right, okay, to understand how technology has evolved over time, especially when it comes to what I was describing, which is don't just look at complex system integration or just buy something off the shelf, but are there actually platforms that will solve my headaches pertaining to integration? And henceforth, I focus on using what is easily available, right, okay, to build this capability upward. Okay, and then instead, right, okay, perhaps spend the time to work with information service provider or service partner, right, okay, to put everything together and call it my own. Okay, so these are the three things, right, okay, that she saw as, and it's also my same advocate, right, okay, in terms of what else can be done. So first and foremost, right, okay, is the idea that a lot of platforms today are actually equipped and pre-integrated. So the ability, right, okay, to create situational awareness and also to have the ability to put a semblance of control tower is actually already in the market. Okay, so be it some technology stack like what my company has to offer, or others, right, okay, that is straight out of, say, for example, Microsoft Azure IoT Hub. Okay, or you've leveraged fully, right, okay, on the entire Amazon AWS cloud. So a lot of these capabilities are already there. Okay, that you can specify and then you build up and you subscribe to the modules based on what you need. Okay, because you don't need everything lots of barrel right from get-go. And you also want to leverage on cloud service provider because your seasonality, right, okay, means that it can be managed that way, and therefore, based on the workload itself, you can actually save some money, right, okay, without having to over-invest in terms of running an operation all the time when you don't in fact need it. The second trend, right, okay, that is very important here is the idea of sensing. Now, a lot of information, right, okay, that is made available is actually because of new data types. Some of these new data types, right, okay, include, for example, IoT sensor devices, telco information, social media information, computer vision information, images, so on and so forth. So the second thing, right, okay, that needs to be kept mindful about, right, okay, is the data type has changed. The data type has gotten a lot richer, a lot more voluminous, and also a lot more varied. And data, right, okay, is now streaming through at such a huge volume that it doesn't make sense at all to take everything in and try to analyze. As much as possible, you also want to push some of the decision making right at the corner of actions so that you need to take in whatever you need to and throw away the rest, right, okay, at the edge itself. So the second thing that was definitely looked into, right, okay, is the effect of new data types, how current things can be, and also the idea of using IoT analytics, right, okay, to be able to get rid of information that you don't in fact need, and then you just settle for it. The last area, right, okay, that was particularly interesting is actually in fact, it's on the proliferation, right, okay, of the some of the AI techniques. Now, for some of you who might be familiar, right, okay, this picture is very simple, right, okay, it's actually referring to a neural network, a simple neural network. Okay, so there was actually, in fact, one more level of study that she went into was to look into when you have got always a delay, right, okay, in terms of not meeting, the actual is not meeting the estimated arrival time. Could there be possible explanation, right, okay, as to why is it that certain KPIs, like for example, the ETA is always breached? Okay, so for a student who is non-mathematical background, right, okay, this lady actually, the student, right, okay, actually went on to run a simple neural network just to establish, right, okay, in terms of the correlation and also the influence, right, okay, in terms of various variables, in terms of how much they contribute to creating a delay in the form of a flight path. Okay, so this is the area, right, okay, that if I amplify it further, is the mathematics capability, right, okay, has gone one more step further. Okay, it's no longer just statistics itself, but the mathematical techniques related to anything from, especially the neural net side of the house, right, okay, plus other machine learning techniques are actually very useful when you really want to dive into some of the root cause analysis or to predict into things like, for example, your ETA. So what all that means, right, okay, is this: if you create a whole situational picture together, the whole situational picture, right, okay, you can start by understanding that I want to build a dashboard so that it provides me with a situational picture. But don't stop there, because there's only the visualization and the exploration. The more difficult part, right, okay, is in fact on the data preparation, the data exploration. Okay, also consider how do you use the geospatial side of the house, which is something I'm going to touch on tomorrow. And then also look into how do you govern not just the models, but govern the access and also the usage. And also how do you actually look into collaboration and information sharing, okay, right from the get-go. These become buckets of capability, right, okay, that could be studied into. It doesn't have to be delivered all at one go, but it has to be studied into because it will help you formulate the bigger picture. And the last thing that I described, right, okay, is some of those things that came through the presentation earlier. is also to understand, for example, IoT or some other graph techniques related to network analysis. Also, the concept of using time and space, right, okay, to converge, okay, so on and so forth. Plus, some of the more newer techniques, right, okay, that you hear about, okay, are related to artificial intelligence and computer vision to deep learning. Okay, how can all this come together to create something that is suitable for you and it's not something, right, okay, that is just strictly already bespoke? So that's it, right? Okay, this is my last slide. Okay, and after that we can take some questions. But this is a SaaS view, right? Okay, as far as we are concerned, in terms of the next generation of control tower or the next generation of situational awareness, what we advocate, right? Okay, is the first three types of capability is already very well documented. You must first and foremost be able to visualize what's happening. Secondly, right? Okay, the second layer here is you must be able to analyze what caused things to happen. The third layer, right, okay, is the ability to connect outward and perform execution. So this is where you really want to be able to work with partners like E2Open, with SAP, or with whoever else, right? The whole idea of transfer and the whole idea of execution, right, okay, is the next layer. Now, this is very well documented as a 3-layer of control towers, right, okay, because several years ago, some academia has published this, and yes, this has continued to stay as the de facto standard. But we're going to argue, right, okay, that there's 2 more layers of enabling capabilities that can transform the operation. One is the idea of IoT and decision making at the edge itself. Okay, now this is where you're leveraging on sensors development, communication development, maybe 5G, if you might argue along that line, so on and so forth, to be able to push some of these activities all the way to the edge and on different data types. The last thing that we'll highlight, right, okay, is this concept called link analysis. Okay, link analysis, right, okay, is particularly important is because from a graphical angle, it actually allows parties to understand the relationship between different nodes in a whole relationship or network, in a whole network relationship, I beg your pardon. Okay, and from there, right, okay, if you understand how things become what they are over time, so 1 week after another week, you start to form a picture. That is the picture over time. What then becomes more important, right, okay, is if you want to investigate backward yourself, you can actually investigate. So today, most capabilities, right, okay, tends to be forward-looking, okay, and not a lot of effort, right, is put on the investigation or the retrospective side of the house. Okay, so this is where we'll provide this, right, okay, as the last point of view. Okay, is from a control tower angle itself, we'll say that first and foremost, the first 3 levels are well documented and we think that it's important. But there are 2 more kind of capabilities, right, okay, that is going to be very useful. One is the idea of IoT and edge decisioning. The second idea, right, okay, is link analysis, where you understand the effect of relationship in a network. At the same time, right, okay, using it, therefore, to be able to perform investigation and retrospective actions. Okay, if we put all this together, right, okay, then honestly, it is a capability that is extremely flexible and agile, and it can definitely address be it a urban logistic conversation, a humanitarian logistic conversation, or just about anything else, right, in the supply chain space. Okay, so with that, I think I will just stop here for now. Just realize that I used up my time as well. Thank you.
Thank you so much, Calvin. That was great. Is there any question from the floor? We can get 1 or 2 questions. Any curiosity for Calvin on this particular portion? I think there was one question in the chat, but it was more about the resources that are required for implementing such systems in the public sector. But I don't like. I can end this to you, Calvin. There is one question in the chat.
Giuseppe, maybe I just I think maybe not appropriate to discuss that here.
Sure.
But I think it's a good question because like what we had earlier in the morning, I think it's a good thing to we're going for a shared approach. But if they want to talk with the respective companies about business, I think this might not be the appropriate platform here. Okay.
Yeah. Dr. I would like to just pass a comment on this topic about if we do create a situational capability, monitoring capability, or call it control tower, especially to serve the humanitarian effort itself. Okay. Actually, to me, the most important question, right, okay, is really to answer to start with, right, okay, is how do we really work on the data ownership and custodianship?
Yes.
Now, some years ago, right, okay, when we were working on Singapore in the case of the National Trade Platform and also the e-freight project, right, the e-freight Singapore project, the same question always come up. Okay, as who owns it? Who owns the custodianship? Okay, and in fact, right, given the fact that this is going to be a 10-country collaboration, I wouldn't pretend that anyone will not have the answer. Okay, it's more important, right, okay, than ever. Therefore, right, okay, to address this question earlier than later, okay, by all the major stakeholders in the program, because that itself, right, okay, can create a major conversation point, right, okay, for all parties from the get-go. Okay, so it's as I advise, right, it's something to look into earlier than later.
Yeah, and I think this is one of the topics that I've been discussing with Temasek Foundation. We would have we would take that in a smaller group of those who are interested to take part in the coming together, like what we heard from Maria this morning. I think all those who are interested to come together, then we can have that discussion in a small group once we know what can be built. But to have it in a large group of about 160 people, I don't think it's going to happen. I enjoyed the talk. So Calvin, I look forward to continuing with you over the break, outside the break. Yeah. Oh, after the break, sorry. We're not going anywhere, we're still stuck at home. Yeah. Okay. Will, you want to announce the break?
Okay, thank you, Bob. Thanks a lot, Kelvin. Thanks for the sharing. Okay, let's take a short break. Let's come back again at 3:30, 3:30. Okay, thank you, everyone. We'll see you in a short while.
Thank you.
Bisa sih. Bang, ini gue itu aja. Iya, laganya di situ sih, di Glodok situ. Hmm? Pak Jajang yang suka kesini itu. Harus baru. Kan kita ada dua nih laptopnya. Ada yang sewa, ada yang kasih aja nomornya Pak Jajang.
Hi everyone, welcome back. Let's turn on our video and take a group photo. Thank you. ไม่ได้บอกว่าอย่างนั้นคือตอนนี้สแตนดาร์ดมันคือมี3ไงแต่ถ้าสมมติว่า
Jimmy, are you done?
Give me 1 second. Okay, it is completed. Thank you for your cooperation.
Thank you.
Thank you, Jingyi.
Thank you.
Thank you, everyone. I hope you have had your coffee or tea and you are refreshed and ready for the next session. Next, we would like to invite Mr. Kelvin Goh again. He will continue with his second session for the afternoon. And his session will be on demand-driven supply chain analytics. Kelvin, over to you, please.
All right. Thank you, Yong. Hi, Yong, can I just use you to confirm for me you can see the slides and hear me?
Yes, definitely. All good, Kelvin.
Thank you so much.
Thank you.
So indeed, welcome back everyone. Thanks for bearing with me. Okay, I'm going to take the next 1 hour thereabout, right? Okay, to touch on something that is a little different. Okay, and it's this concept, right? Okay, of a demand-driven supply chain and also the account analytics, right? Okay, that comes along with it. Okay, and in fact, this particular conversation, right? Okay, because of the very wide group of audience that we have here. Okay, I will first and foremost cover some parts of it more from a commercial point of view, okay, as to how this is being addressed. Okay, typically, right, okay, in e-commerce and also other kind of scenario, okay, retail CPG. And then after that, right, okay, I will go on to stitch some of the picture, right, okay, a little closer to the humanitarian logistic and relief sort of an angle, right, okay, so that we can also understand from how is it that we can use some of the commercial practices and apply it, okay, in a more specific scenario, as in the case of humanitarian and disaster sort of a situation. Okay, so the good learning is definitely transferable here. Okay, so please bear in mind, right, okay, while I go through the next part of the presentation. So I'll start by putting the title header here, right, okay, for all to see. Okay, so I'm going to start by discussing, right, okay, pertaining to there's actually a big shift in terms of fundamental dominant logic. Okay, and I'll describe what it is, right, okay, and why is it that there's a lot of changes that we actually experience, not just from technology, not just from what are the kind of capabilities, right, we're starting to see. But what's more important, right, okay, is how it has changed you and I, okay, as consumer. Okay, the kind of demand that we have put on our logistics service provider, right, okay, I think it has never been this harsh before, okay, until now, right. So I'm going to point out some stuff, right, okay, that you all might be aware or you might not be aware, but I'll try to describe, right, okay, why is it that it came to be like this, right. The second thing, right, okay, that I'll definitely be trying to connect it to is using analytics, right, okay, to drive the same paradigm shift, okay, that could be applicable to humanitarian logistics. Now, as we later progress into other kind of workshop sessions itself, we'll go deeper, okay, into some of these topics, right, okay, where we look into the specific demands, right. But I'll just put on the context here in terms of the high level, okay, as to what we can learn from the public sector, from the private sector into the commercial sector, and how that might actually be applicable into the humanitarian aspect. Okay, so this is how I will prepare to deliver the session later. Let me get going here. Now, first and foremost, right, okay, let me introduce this slide to all of us so that we are very clear as to what is a demand-driven supply chain or a demand-driven sort of a paradigm shift. Now, that is the best way to look at this, right, okay, is without you having to go into all the academic literature and studies, right, okay. Let me put it very simply across to all of us. Okay, traditionally, supply chain, right, okay, as the word suggests, supply chain, okay, it's actually a supply-driven practice, right. So it's a case of the producers producing something, okay, and then it goes through the different stages, right, okay, and in the end, right, okay, it get delivered and then finally consumed by the consumers. Okay, so our supply chain in the world, right, okay, traditionally is in fact designed to behave this way, right. So you can imagine, right, okay, if you are a farmer, okay, you'll be trying to get the maximum yield. Let's say you are planting carrots or potato, right. You'll be trying to get your most out of your land, okay, and then you perform crop rotation perhaps to get better yield. And from there, okay, you try to put in some semblance of technology so that you can produce more, so on and so forth. But the fact of the matter, right, okay, is the farmer is trying to get the most out of this land and hoping that they will get a good price, right, okay, for their produce. Does the farmer actually know what is the demand for his products? Actually, sometimes the answer is maybe not, right? So that itself, right, okay, is a first illustration point, right, okay, that very often from a supply-driven concept itself, people are just producing, and their KPIs is more after cost, after economies of scales. Okay. Second thing, right, okay, the role of the intermediaries. Now, the case of intermediaries is also the same. Okay, a lot of time in the past, in the supply-driven supply chain, the participant there, right, okay, all have a concept of build to stock, right? They will build things and then they pass it over, try to design a delivery and fulfillment network with warehouses, forward stocking location, but not really knowing, right, okay, whether those things will move or not. And then after that, they retrospectively study into the inventory, understand it from the day sales on hand, try to understand from how long they stay in the warehouse, and there say that, oh, some of these items are actually slow moving, therefore I don't stock it anymore, or for the matter, right, okay, is I'll reduce certain distribution, something like that, right? And then when you finally go to the retail, very often, right, okay, I think a lot of us will be familiar. You see that there's a lot of produce in the supermarket, for example. And very often, right, okay, like for example, I just had an example, right? For example, potatoes, right? Okay, why is that potatoes are always in very big bags? Okay, I think there's a good reason, right? It's because over time, right, it has become to know that certain packaging is easy for delivery, easier to stock, easier to move, so on and so forth, and henceforth, they are packed in a certain way. Okay, so all this, right, okay, they are all signs, right, okay, of what we call a supply-driven paradigm, okay, whereby it's all about the production process, and it's not so often, right, okay, having the consumer in mind. Now, especially the proliferation of e-commerce itself, that has changed dramatically. Okay, and increasingly, right, okay, there is a shift in the paradigm to something called demand-driven or service-dominant logic, right, okay, as a way, right, okay, to talk about how demand now is driving behavior. So if we compare it, right, okay, at the bottom layer here, this is going to be a little different. So first and foremost, right, okay, the starting point, you actually consider what does the consumer really want. Okay, and the consumer actually have a choice, right? Secondly, right, okay, you also notice that instead of a very thin and also straightforward line, the intermediaries has changed. The intermediaries, right, okay, in this case here could be changed to not just one distributor or one stockist, right, okay, but it could be many, many more. So when we talk about the proliferation of e-commerce itself, you can notice that the same item can be resold by many parties via different e-commerce platforms. At the same time, right, it's also possible that they use an omni-channel strategy to actually reach out to the customer in so many different ways, right? The third thing, right, is it tends to be more targeted, okay, especially when certain industry, like for example, those that's dealing with green industry, the recyclables, renewables, okay, it tends to be more targeted, right, in nature, and it's not about bulk. Okay, so it tends to be a little bit more focused in terms of who are the farms, where are the suppliers, and at the same time, right, what are the factory customizing. So anybody, right, from Nike all the way, right, to Impossible Burger, you are noticing a change, right, in terms of when it's demand driven, the entire setup is fundamentally a little different from what is a supply driven sort of work. Okay, with this in mind, right, I will use another way to present this, right, and say that in a supply-driven world, right, it used to be one size fits all, very few channels. Okay, at the same time, right, it was actually all pre-configured so that it is shipped effectively, stocked effectively, very hard to, is flexible, hard to customize. The plan, right, is always based on the previous sales, and then economy of scales drive the whole thing, and then what they're after, right, is cheap to produce, cheap to sell to us customers. In a demand-driven approach, right, or a service-dominated approach itself, the behavior is a little different, right? It tends to be more focused on the customer, more interested, right, in having many channels. There is also it created an explosion of different SKUs because of the configuration. You also need to look into a shorter demand sensing cycles because things change very quickly, and you need to be able to catch up with with reaction. And at the same time, right, we are also looking at new ways whereby you can shape the demand so that it all don't come to you at the same time. As a result, it actually breaks your supply chain. Okay, and then also this very important thing about the role of real-time data. Okay, so this summary here, okay, is not meant to tell, it's not meant to say what is good, what is bad. Okay, it is just displaying a list of characteristics of a demand-driven supply chain versus a supply-driven one. Okay, so this is the first part, right? Okay, that I'd like to set the stage in terms of explaining from here, right? Okay, as to how all this concept come together later when we talk about a demand-driven supply chain and the analytics that comes along. Now, fundamentally, right? Okay, whether it's supply-driven or demand-driven, the most preferred world, right? Okay, as a whole community, as a whole world of people, right? Okay, if only we can achieve the idea of having the right product in the right amount, always at the right place, and then at the right time. Now, if the world, right, okay, is really like this, then I think we can talk about a lot of wastages will be eliminated, a lot of abuses, so on and so forth, right, okay, will kind of be eliminated. So a demand-driven supply chain, just like a more conventional one, still has its processes, still has got its matrices, right, and it has got its results that it has to deliver. But the difference here, right, okay, is the results that is after the matrices and also the processes actually has changed. Okay, why? Because it's now no longer trying to achieve the idea of economies of scale. It's not trying to achieve the idea of the cheapest item made available to the customer. Okay, but instead, right, okay, it's looking for best place, time, utility. The idea of having the right thing for the right party who wants to consume it. Therefore, right, okay, the actual benefits, right, okay, that you can derive is actually higher, the utilities. Okay, so these are, I think, economic concept that I think we're all familiar with. The idea, therefore, right, okay, is what do you need to really change, right, okay, from your processes, the matrices, and the results. When you compare it to a supply-driven one, so that you can actually strike a balance and you are able to react to whether is it supply or demand accordingly. Right. So this is where this is a SAS chart. Okay, as a company, we have written and published countless books, right, okay, on this topic. Okay, on the idea of demand-driven supply chain, demand-driven supply chain analytics, demand supply chain optimization, forecasting, so on and so forth. Okay, as a company, right, okay, we have published countless books in this field. Okay, but what is it that we are really advocating, or what is it that we are kind of providing information to the world, to anybody, right, okay, who is interested in this topic itself? We actually got to look at it, right, okay, from a few dimensions. Okay, first and foremost, right, okay, is a demand-driven supply chain itself has got certain characteristics, right, okay, that we see on the boxes that is captured here. Okay, now first and foremost, right, okay, we start by looking at the center. The supply way of doing things is you look at your sales processes, you look at the planning processes, and then you put it together and say that this is how much I need for the next season, for the next year, for the next preparation of actions. Right? This is still relevant. Okay, in fact, right, okay, it has become even more relevant than ever when we talk about a demand-driven supply chain. Why? Because in the past, right, okay, like I said, a lot of time people just attempt to build the cheapest unit and then you build to stock. Whereas in this new concept here, right, okay, you actually got to find ways whereby it can give you the most accurate information, the most current and useful information, right, okay, so that you can actually use it to do your planning. Okay, so even more than ever, the whole SNOP process, right, okay, has actually stepped up to the point whereby the sensing become a critical ingredient to be able to provide the right ingredients in order for you to plan, okay, and make it into a very effective demand-driven supply chain. That itself, right, okay, is the crux of what is a demand-driven supply chain. Okay, is to be able to sense what is the closest on the ground, understand the demands in the best way that you can with the information that you're collecting, and then you build your entire fulfillment strategy, right, okay, behind that. Okay, so with that in mind, right, okay, this is actually a fairly important diagram because it actually introduced a few concepts, right, okay, in terms of from a demand angle, what can you do? Now, supply side, we are already familiar, right, because we traditionally it's always been supply side driven supply chain anyway. Okay, so when you are building something and then you forward stock it, when it's consumed, draw down, you replenish, right? That is a concept that's already familiar. What is less familiar, therefore, right, okay, is what can you do from the demand side or on the demand side in order to get even closer, right, okay, and therefore address to this new shift in terms of customer demand and the change in the paradigm. Okay, so I'm going to introduce just 3 words. The rest of it I will not touch on it. Okay, but demand-driven supply chain, right, okay, has got a few big concept here. Okay, there's the idea of demand sensing. So really understanding, right, okay, how much demand is there on the ground. Okay, so you actually got to use all sorts of ways, right, okay, to be able to find information that gives you the best sensing as to what really is the demand. The next, right, okay, is the concept of demand shaping. Now, demand shaping, right, okay, is because under the assumption of the fact that you can actually use your 4Ps in marketing, right, okay, you will actually be able to influence the amount of demand there is. Henceforth, demand shaping, right, okay, is therefore a technique that is used in order to move the demand to and fro between different parties, right? Okay, say, for example, you provide discount in one store, but you don't provide discount in another store. So you move the demand, right, okay, because there will be parties who are willing to travel a little more distance, right, okay, just to get a better price. Okay, these are examples, right, okay, of demand shaping. And then demand shifting, right, okay, is more from a time angle, whereby you try to delay demand, okay, like for example, you change the price point, right, okay, to something higher, okay, or you try to move forward the consumption, right, okay, by providing certain kind of promotion, okay. So these are the different demand techniques, right, okay, or demand side techniques that could be used in order to kind of get to an optimal point of demand, and from there on, it uses the rest of the setup itself to produce things at a optimal level, okay, optimum pricing level, and optimum fulfillment level. Okay, so this is the big difference, right, okay, in terms of what is demand driven versus what is supply driven. Okay, I'll go on from here. Yeah.
Calvin,
Yes.
can you take a second to pause? I think Harlan has a question, or you would like to add something on demand driver and supply chain. Yeah, Harlan, over to you.
All right, thank you. Yes, yeah, thanks, Kelvin. Sorry. As I was listening to that, I really like the way you break down what's the difference in the two. And what came to mind to me was, as in the humanitarian side, let's ask ourselves, who's the customer? Is the customer the beneficiaries, the people affected by the disaster who we are trying to supply? Or is the customer the donor that's giving us the money to meet the needs of the people?
Yeah.
You know, from a donor perspective, you know, basically, and from an operator or humanitarian or government perspective, often we look and we see a disaster and we say, okay, there's these people impacted this way, so everybody needs, you know, a food package, a shelter package, and we kind of determine what they need based upon experience, based upon international standards, practice, whatever. You know, we don't often go and tailor the package of aid to individual customers or even, you know, a group. Now, so we design that, you know, on the front end. So in some ways, it's very much like your supply-driven model. We determine what the customer needs. We develop the packages, you know, and we send it down the system and give it to them, and hope that it meets the needs of at least 80%, you know, of the population. We know that it doesn't. Now, you know, flipping that the other way, you know, on the demand side, one way we are trying to address that sort of some of the problems that have occurred with that supply side approach, you know, has been to distribute cash, and therefore people can make their own decision. But that's only a valid option if the local market system, you know, is that the commercial suppliers are actually supplying and have present the materials and things that people need following a disaster, so they can use their cash on. So sometimes the market and the commercial system is equally impacted by, you know, by the disaster in the area, you know, and they may have some supply problems as well, so of filling their stores. So the other point is like bringing down materials as far close to the people as possible. They're basically the raw materials to make your product being a package of aid, and doing some kind of a package assembly closer to the people based upon individual characteristics of demographics of women, of children, of this, of that, or requirements somehow where you've gotten to people and said, what do you need? But I think that the system definitely in the humanitarian side generally starts with a supply-driven approach, but then should try its best to transition to a demand-driven approach. Once the scope of the problem, your customer base, once you understand who your customer base is and for how long you expect to serve them, switch over to that more demand-driven approach. I wanted to put that forward because I'm going to have to sign off. I got called to another meeting that's happening in just 5 minutes, but I will join tomorrow. But I wanted just to put that out there. Like I said, I really like looking at that from both from a commercial and then applying that to, well, what is it in our humanitarian context? And to me, the big question's always been, who's the customer? Okay, thanks.
Hello. If you might allow me, right? Okay, in fact,
Yes.
I do have some content that's very specifically targeted at what you just described. Okay, and it's actually related. It's actually from the learning, right? Okay, in terms of the work we have done with the IMO. Okay, and specifically, right? Okay, addressing it for the learnings, right? Okay, from the Nepal earthquake. If you might just hang around just for maybe 5 more minutes, right? Okay, I might be able to show you some of the work done there. Okay, especially how do we combine the demand-driven approach to exactly solving what I just described? Exactly right. The bill of materials cannot be generic. It has to be tailored to what is the local condition, local populace, culture, so on and so forth. So if you can just hang around for about 5 more minutes, I'll show that to you.
All right, I'll try.
Okay. Right. I'll come back later, right? Okay, on some of the more generic slide. Okay, I'll go straight into how this concept, right, okay, is put into the humanitarian logistics. So sorry for the rest of the audience, right? Allow me to just jump into this because I thought this is pretty important. Right. Right. So this is something I'm going to touch on now. Okay, is how we actually use data analytics, especially when it comes to bringing in the elements of demand-driven, right? Okay, to use it for humanitarian purposes. Okay, so I'm not going to cover this. I'll come back to this later. But let me play a couple of videos, right? Okay, that could be very inspiring, right? And then we'll discuss, right, okay, exactly what is happening here.
पैसाले आएको बेलामा पहिलोचोटि हल्लाएको अनुभव भयो त्यहाँबाट माथिको झऱ्यो घर छोडेर बाहिर बस्नु परेछ
You all can hear the sound.
Chautara town is the capital of Singapore municipality. 66,000 families. They have a very difficult situation coming. The monsoon rains are heavy and the winds are strong. Plastic sheeting and tents are not going to make it at 4,000 meters. We have to give people their dignity. We have to give people shelter. Corrugated iron sheeting is a construction material that's favored by many rural Nepalis in order to build their roofing. But how much raw material must be available in the country to produce that much iron sheeting? How much could be taken without causing problems within the prevailing market forces? Because we have to not help 1,000 families or 500 families, but 10,000 or 50,000 who are in camps all throughout earthquake-affected Nepal. Where does all that CGI come from? That's a complicated sweet spot, and I couldn't do that myself. I'm glad to say that there's a guy in SAS named Isa, and I was able to communicate my problem without a solution.
He said that he had 45,000 families at the time. They needed to find sheet metal roofing fast. And so, but he didn't know where to get those answers.
We did some work with the United Nations. looking at comp trade data. So trade data from any country that's initiating trade.
I literally put them on hold, went and searched 300 million rows of data in visual analytics.
Production capacity, labor migration patterns, vocational and technical capacities. What SAS can do is analyze a broad spectrum of data to understand my population better.
Within a couple of minutes, I said, you know what? India, right next door, is the world's largest producer. And oh, by the way, Nepal ranks 7th in the world before the earthquake. You may even still have some capacity in country.
I placed an order for 310,000 sheets of 26 gauge corrugated iron sheets that, as we speak, are starting to go on the roofs of people's houses.
That's stuff that matters. Being able to find trends that are going to positively impact people.
And I'm not even sure what kind of algorithm was used to give me the data that I needed to make decisions. But what I do know is that in the end, it's allowing them to rebuild. And that feels pretty good.
Okay. So I don't know if how long is to that, but I will just continue. Right? Okay. I hope you saw the video earlier. Okay. That was really a case, right? Okay, of trying to use analytics to really visualize very quickly as to what's happening, and then you tailor the needs on the ground, right? Okay, from a supply chain angle, and then get it to serve the local community. But the best thing is the story doesn't stop there. Okay. In fact, right, okay, after that particular initial understanding of the ground itself and also the problem pertaining to shelter and roofing, new problems, right, start to come about, right, okay, and y'all will hear it in another very short video that's going to come up. Okay, it's because when we were working on the data itself, my good friend Isa, okay, the one that you all heard from, okay, Isa actually started to realize that they were looking at it from the from a certain angle itself. The local populace, right, okay, the most vulnerable group, in fact, right, okay, were young children. And the young children are all over Nepal, okay, because all the center of attention was given to Kathmandu at that point of time, okay. The rest of the region, right, were in fact neglected to the point, right, okay, whereby it was posing a level of danger, okay, for the other parts of the country, okay, in terms of the populace, okay. So upon further investigation, right, okay, that's where we start to look into the disposition, the age group, the demographics, and also understand that in fact the other region, the larger need is related to things like, for example, the milk formula, okay, diapers, so on and so forth. Okay, so this is where the next level of catering, right, okay, or adjustments, right, okay, it was made because people were asking the right questions. Secondly, right, okay, IOM, in this case here, the parties that were focused on immigration, they also realized that when everybody is rushing in to assist a disaster area, it needs to be coordinated. And it's hard to imagine a central agency having to do everything. So they were asking all the important questions so that they can disseminate then the information to the rest of the ecosystem partners that's trying to address different aspects of the entire disaster recovery effort. Okay, so the next part of the story, right, okay, will be as such, okay, and then you all might allow me to just roll the next video. So this 1 month later, right, okay.
At the onset of a large-scale disaster, you have a large number of humanitarian organizations that turn up. Information and any data becomes extremely valuable. Everyone is keen to make sure that the most vulnerable are provided with service.
Being able to leverage the data to its fullest extent possible is helping us to better target our responses on the ground. We were thinking of covering first the insight you had sent us an email on.
That might be interesting. So I put all of the sector support variables up here.
Yeah, we can see it.
So when we look at the 66 camps, Kathmandu has hardly any girls under the age of 1.
This morning, we were looking at protection concerns in the sites in which age groups are more vulnerable.
Okay, and that brings us to these 8 camps here. Out of the 400 some odd females, almost half of them fall under the age of 5.
We want to be the one to flag issues to other agencies to make sure that these people are on their radars. Because what we also track is where people are coming from and how we can support them to return.
हजुर म ठुलो मान्छे हो सबभन्दा हजुर म विधवा हो 5 जना बच्चा पढाएर सानो चिया पसन्छ
त्यसले 5 बच्चा पढाइरहेको छु
With mobile data collection devices, we can basically assess the information in the morning, analyze it in the afternoon, and disseminate it in the evening.
Philippines have 4 values. Myanmar have 3. Nepal have 2.
Getting people home depends on timely actions. SaaS helped us to start thinking about predictive analytics and using our data in anticipating what is coming next. That's very powerful. Becoming more efficient in humanitarian relief is something that excites me personally.
Right. So I kind of like decided to close off the video for now, right? Okay. Just so that we can discuss a little bit, right? Okay, pertaining to the role of therefore demand-driven analytics, right? Okay, in the area of humanitarian logistics. But more importantly, right? Okay, how do you actually connect it to the topic that earlier Holland was talking about? And you actually then, based on the insights that you're mining out, you collaborate actually with the donors and also the e-commerce world, so that you can actually create a new chain of activities that could really serve the purpose, right, okay, of humanitarian logistics in a way that it was never done before. Okay, so I think, to be honest, right, okay, we were particularly excited as a company to be involved in this whole conversation was because we saw that this is actually very innovative, not to mention that it actually leverages on what is out there at our disposal, right, okay, to really create a new layer of capability not seen before. Right, so I kind of like just want to use this chance to show that some of the videos and work done earlier first, because it actually connects very nicely, right, okay, to from demand-driven, the idea of sensing, the idea of then you perform the right kind of analysis, so that you can configure based on what is actually required, continue to ask more questions, and eventually, right, okay, see to the fact of using your donors' money wisely and also kind of connecting and plugging in, right, okay, into the e-commerce world. There is a very different one now called e-commerce world, right, okay, where you can actually leverage on those networks to be able to solve humanitarian related kind of the challenges. Okay, so I think that's in a way, right, okay, one of the most important message that we'd like to deliver in this session. Okay, so guys, just take a pause here to see if there's any other questions before I go back to some of the earlier content materials. Does it make sense to anyone, or is doesn't make any sense at all?
Anyone has a point for Calvin? Input, just a comment? Thomas, over to you. So you raise your hand.
Yes, okay, just a question. Demand-driven supply chains, okay, we've been working on that for a while, but how do you do that in an emergency situation? Okay, I was in Nepal. The question here is, it takes quite a while until the demand is really known. Okay, so how do you deal with that when you have incomplete data?
Just if I may, Calvin, I just step in. I think, when you're talking and like what Harlan was mentioning earlier about the demand-driven, I don't think, when you're seeing the tools from SAS, I mean, they can do that almost rapidly, yeah. But I don't think that you can do that as rapidly if the whole systems are not integrated, yeah. But what you can do is that if you had the historical data from many disasters, right? You can anticipate what those requirements could be smartly because they have the tools, yeah. So you could make it a demand-driven and not supply pushed, yeah. You understand what I'm saying, Thomas? In the sense that if you had historical information, you could anticipate the future, a bit like what Amazon does. Yeah, this is what you bought in the past. Yeah, now I can anticipate what you might want to do, what you might buy in the future.
Yeah, right. This is what we usually do in humanitarian supply chain.
That's right. That's right. And so, but when you want to make it really live and say, this is what I need now. Yeah, and so where can I source it from? then that is an extreme form of demand driven, yeah, because that's actually doing it quite like to search for the sources and then hoping that once you've found the sources that you can have it, pushed all the way to where it's required. And I think this is why, we really love working with SAS, yeah, because we're bringing those tools together.
Okay, I understand. Thank you.
I might just supplement a little bit there, okay, to Mr. Thomas, right? Okay. So, any kind of disaster or crisis situation, okay, it actually goes through stages. Okay, and I think, again, in the academia world, right, okay, it's very well documented when it comes to disaster management cycles itself. There's a certain framework, right, okay, and it actually illustrates the time frame and activities, right, that involve. Okay, case in point, right, okay, if we talk about demand-driven, instead of thinking of, at that point in time, I got data missing, I have got information that are not complete. Our question, right, okay, will always be, what can we count on from the first responder? What information is available that is from the people on the ground? This is this, right, okay, information that is actually available publicly. Now, I spoke at length, right, okay, in terms of new data types. Now, if you're thinking of, I need 500 bits, 20 measures, right, okay, and expect it all to be served to me on a platter, okay, I think that is a very old way of looking at data and the problem. A different way of looking at things, right, okay, that I'm very familiar with is, for example, crowdsource information and understand what people are talking about. So when we combine it, right, okay, with social, okay, especially information, when you are able to then respond according to what is really most useful to the beneficiary. I think as logistic practitioners, right, okay, what we hate the most will be a case of things coming to you, right, okay, unannounced, okay, or unanticipated. Okay, if you can turn the problem around, right, okay, to make sure that what is coming to you is in fact what you asked for and what is anticipated, then I think, right, okay, the operation in the future, right, it will not be as opaque as in the past, when you really has got all these data silos, right, and not sure what is actually happening. Okay, so what really I'm saying here, right, okay, is there's always the potential of things becoming better as the time space out, because there's a sequence to the cycle. And secondly, right, okay, is the potential of using non-traditional data sources, right, okay, that is very powerful when it comes to augmenting and also creating a new situational picture. Okay, so we will look into anything, right, okay, from images, satellites, so on and so forth, right, okay, and also what people are talking about. Okay, all this will create a new sort of you can say that it just creates that new level of situational awareness, right, as compared to more static approach in the past. I hope that makes sense.
Okay.
Any other comments or questions?
Calvin, I think this comes up with the idea like what I was speaking about much earlier, like almost like virtual stockpiling, you know what I mean?
Yeah.
Because that's the sourcing by the crowd anyway, right? So that's crowdsourcing. But when you have a structured system and you don't allow the unstructured activity around it, that means therefore there's a conflict. You know what I'm saying? Now your system allows that, that means you can handle the conflict, right? Because you can merge it. But when and this is something when I see that if you have a highly structured system to respond, and then you want to add in the that are unstructured. If you don't have the tools and technology to do that, it's a mess. It's chaotic. I mean, as you know, the military can do that very aptly, right? They can bring things in when they needed it, very short supply. Yeah, I mean, with very short lead times. So I think that's why I'm asking in the group, kind of saying, if you want to make your system highly structured, then you don't allow the flexibility or the agility. But if you allow some degree of agility, then you can actually handle the demand driven, but not to compromise on lead times.
Yeah. So I think as with when it comes to system design, so and so forth, I mean, this is not the time to talk about some of those things, but there will be a few major considerations, right? Okay, exactly because some very structured product, okay, will have missed opportunities in terms of how do you harness all the more dynamic or more flexible aspect. Okay, so case in point, right? Okay, when we talk about system design or platform design here, a couple of things that will always come to mind. Big words like, for example, it must be open. Okay, it must be scalable. You must be able to scale up and scale out. Okay, concepts like this, right? Okay, will come into play later. Okay, because it does again offer a different kind of opportunities, right? Okay, especially when it comes to a topic like this itself. We're not even talking about seasonality. We're talking about events that is ad hoc in nature. So there's a amount of planning that you can do in advance. But you also need to have the ability to really react to it based on what else is coming through to you. So the military, right, okay, for example, they are very good at this is because they have got the concept of fusion, right? They're always fusing the information together, regardless of what system they're using. The fundamental concept is how do I fuse information together so that it can guide my next course of action. So I think that will be a good guiding principle as to what any kind of system should be aiming for. Is that layer of flexibility, right? Okay, so that it is not just providing a certain structure, but more importantly, it provides you the chance to kind of catch the opportunity, right? Okay, that comes along with new techniques, new data types, so on and so forth. So if we can, in fact, I would just like to go back to the materials, right? Okay, kind of just pull out a few more because I wanted to bring forth the idea of what therefore, right, okay, is some of the forecasting capabilities, optimization capabilities, and more importantly, right, okay, in a very dynamic world that is always changing itself, are there actually new mathematical techniques, right, that you can adopt so that you can actually address to a very rapidly changing environment? Okay, so you all could bear with me, right? I'm just going to pull out the slides again, and then I'll just finish it, right, okay, by addressing some of the topics. So this is where I actually left off after I showed the two videos. There were in fact a bit more of the commercial stuff, right? Okay, I think when I was going through the slides, you could see there were some other pointers, but I'll just move ahead, right? Okay, and show some more things. Okay, so demand sensing and analytics, right? Okay, in crisis, honestly, right? Okay, it is to serve a few purposes. Okay, it is to really try to identify the crisis earlier, send the relief to where it's most needed, predict the future. Just now, one of the keyword from the gentleman that was interviewed for IOM itself was from just knowing what is happening. Now they are starting to ask questions pertaining to what are the things that's coming up. Okay, and therefore I can do certain level of prediction. Okay, and therefore I can plan ahead. Okay, and that is the whole idea, right? Okay, and it's a form of demand-driven case as well, because you're actually trying to anticipate what are the things that need your attention, and therefore, right, okay, you're paying attention to those areas. Okay, so let's go on, right? Okay, and just complete this conversation in terms of what else. Okay. So from a system angle, right, okay, when it comes to doing the data aggregation, and then from there on, you start to work on the analytics model, create the insights on the dashboard. I think we already discussed this, right, okay, in some of the earlier sessions, but the general concept, right, okay, will always be the same. So to Mr. Thomas' point earlier, right, okay, data will never be perfect. That one is a fact, okay, and we don't expect data, and we will never go under the assumption that data is perfect. But data can be collected in so many ways, right? Okay, like I mentioned, it could be from first responder, it could be IoT data, it could be social data, it could be computer vision, it could be satellite imageries, it could be some of the latest news that has been broadcast so that we may actually mine what people are talking about. There are many ways, right, data can be relooked at, okay, because there is simply a lot of opportunities there, right? So that's it, right? Okay, this is an example of the solution that I was talking about. That's from SAS, essentially. Okay, so I'm not going to go into details here, but essentially what we can do is to visualize it and also run some of the prediction and also forecasting model based on the scenario that is of interest, right? Okay, and from there on, you can start to build the demand plan and also the supply plan. Okay, this we will not cover here because this one will take a whole day, right? Okay, if we are going to introduce this capability. But what are the real things, right? Okay, that the real sort of magic, the real secret sauce that goes into that. So first and foremost, you can imagine when it comes to forecasting itself, there's a whole bunch of ingredients, right? Okay, that you need to know or you need to have at your disposal in terms of information. Then you can create a forecast model. And then you have a situation, right? Okay, where the forecast, even though it's over some kind of a time series, it can address retail. It can address, right? Okay, what happens to shopping, right? But it cannot address when the next disaster is going to happen, right? That's it, right? Okay. There are certain techniques, right? Okay, because of the evolution, because of the development, right? Okay, in machine learning, where we actually turn some of the forecasting cycle to very short-term ones. Meaning to say the time interval has gotten very narrow, so that we are able to observe certain behavior and therefore do a forward forecast much faster, and definitely don't have to require the whole long duration, right, to be able to get a sense of what's going on the ground. Okay. So this is actually the diagram that I wanted to pull out in terms of the demand sensing process. Okay. So, well, historically, right, we'll be looking at some of the primary data inputs that we see here. There are other kind of inputs, right, that could be very useful, right? For example, in the retail world, that would be the point of sales, right? The point of sales, right, literally at the end of day closing itself, you already know what will be the demand, so you will know how much has been sold. Therefore, from there, when you plot it over time, you therefore know what will be the likely demand, okay, at least with a fairly high level of accuracy. There's so many different techniques there, right, okay, that honestly, data scientists or this kind of business analyst role doesn't really need to choose one. You just let it run by the system, right, and the systems will find the best fit and therefore give you some of the best prediction. Okay. On the flip side of the house itself, there are also other kind of data types, right? Okay, that's not the structure. Like I said, some of the social information, so on and so forth. All these can actually add on to provide a different layer of situational awareness, right? So that's it, right? Okay, what we are really advocating here is there are capabilities that you can let the system run on its own, but as long as we understand that the demand sensing can be looked into, the idea that you can actually harvest and harness some of the real-time demand signals, okay, at the same time, right, okay, trust that there are some mathematical techniques right now that is able to address faster prediction cycles, faster forecasting cycles. Okay, at the same time, right, okay, there are so many different ways, right, okay, whereby you can reduce certain volatility and biasness inside your models itself. This all together, right, okay, with some of the design principles of enterprise software, will be able to put everything together, right, okay, into recommendations. Honestly, they are answers, right, okay, to the questions. Okay, therefore, it creates an improved response time. Now, it sounds like marketing talk that I'm talking about. Okay, but if you are familiar with some of those topics that I'm describing here, right, okay, especially if some of you might be data science trained, then you will know that actually these are all not fiction, right? Okay, they are all possible. It's a case of having to find a platform that is open enough, at the same time, right, okay, flexible enough to work on the different data types in the different scenario, in terms of different scenario planning. Then you can achieve what I just described. Okay, so it is not science fiction at all. It's more a case of what is it at our disposal, right, okay, to materialize a vision like this. Right. So this is the last slide actually. Okay, it's really talking about in a very rapidly changing environment itself. Okay, to really be able to create and enact a very responsive system itself. Okay, you really want to utilize, right, okay, not just some of the structure that is currently available or is already in place, but you layer it with more information, more data type, and honestly, right, okay, push yourself, right, okay, to have fastest answer using less information. Okay, that's the way that things will go, okay, in our opinion, and that's the way, right, okay, that you can actually build up. The moment you experiment with it, right, okay, you will start to see that the extra piece that you add on time and again, from learnings previously to also really asking more questions, right, okay, all this will help to train the system out, right, okay, to be a lot more responsive and honestly a lot more agile and efficient. Okay, so with that, actually I will end the sharing here, okay, because this session, right, okay, was really meant to illustrate the difference between demand-driven versus supply-driven. At the same time, right, okay, showing how both visualization, situational awareness, and also the use of analytics, right? It will allow you to ask a lot more questions, and therefore, right, you are able to do some forward planning. With the forward planning itself, right, then you can design a whole process and protocol to be able to respond to many types of scenarios. It will never be perfect, but it will definitely give you more answers, right, okay, from the get-go, from the time something happens. Okay, so with that, right, okay, I'll just stop the presentation and the sharing.
Thank you so much, Calvin. This was very enlightening. Thank you. So actually, while you were speaking, Juan from the International Federation of Red Cross was sharing some inputs on possible tools to fine-tune a little bit the demand accuracy. I might, Juan, you may want to share your thoughts and your inputs with the group.
Thank you, Giuseppe. Thank you, Calvin. Can you hear me?
Yes.
Okay, sorry, because I'm connecting from home and sometimes it doesn't work very well. I think I'm leveraging a little bit on top of the discussions that they were introduced. Sorry, I forgot the name of the colleague from USAID before. And yeah, it's about how we can include, as Kelvin was mentioning, additional data sets. Traditionally, we might not have been using. I guess that the new technology and the new ways of analyzing technology on social media can be really powerful. I understood that there are some initiatives, but some humanitarian organizations across the world, probably in Southeast Asia, some of them. So this is a little bit kind of new kind of data sets and a little bit out of control of humanitarian. On the other hand, I was thinking on more what, at least from humanitarian, we can do something a little bit more. What is in our hands could be something that, well, we have been trying. It's not that we have not been trying. But yeah, from us traditionally, from humanitarian organizations, is the split between the supply divisions or logistics departments in humanitarian organizations and what we call the programs. Those departments or units that they are really engaged and in contact with the communities. These are the frontliners. And yeah, as it has been mentioned, it's quite difficult, especially at the beginning of an operation, to quickly capture quite good enough information. So that's why usually we use more the prepositioning strategies, long-term agreements with suppliers. But the product definition, even not just only even the type of products, but even the product definition, it has been by international standards and a little bit like we have been doing this like 20 or 40 years, and it's quite difficult to change this. So something that is a little bit more on our hands is more the community engagement and accountability programs that humanitarian organizations we little introduce together with the digitalization. Also, humanitarian organizations, we are a little bit probably behind more kind of the private sector, but we are catching up little by little also because, as you have been explaining before, the type of technology and kind of the price also has been reducing dramatically. So I think it's in our favors. I think there is still some kind of way to move forward on how we can collect more information from kind of communities we are serving, pre-distribution, but especially from supply chain post-distribution. So it will be a little bit, I mean, what we have been distributing, was it really what the communities they were expecting, and was it received at the time that they were expecting? So yeah, just only to leave some, and for us, we have seen also, as the colleague from USAID have been mentioned, that a lot of the push or the interest in doing so has been more the introduction of the cash-based interventions. They are much more aware of trying to capture as well what the use of this kind of assistance has been done. If it is unconditional, it's quite much more difficult because it's very difficult unless you do surveys on how to really analyze what the population have been using the money on. If it is conditional, it's a little bit much easier. It's in our hands. So just only leaving some ideas in there. And for me, it's complementary one to the other. But some of the kind of data sets in-house that we are getting more and more and digitizing is this kind of engagement with communities. Probably will be a little bit more kind of a structure, but there will be chance as well of more qualitative information on these kind of interactions with communities, and somehow also how this could trigger to redefine the stock strategies, the preposition stock strategies.
Pepe, may I just give a response to Mr. Wan here?
Sure, absolutely, yeah.
Right. So, Wan, thank you for your feedback, right? Okay, and I wouldn't say that I'm anywhere close to an expert in terms of this, the whole business of humanitarian. Okay, that one, you guys are probably a lot more, you know, like a year ahead, right? Okay, knowledge. So I will never claim to know more, right? But I would like to share one very a good point, right, pertaining to this whole idea of social. Okay, and in this one project that SAS is doing right now, okay, with some of the organizations, right, okay, because we realize the potential of this big word called crowdsource. Okay, not cloud, okay, crowd, CROWD, source, SOURCE. See, the thing here, right, okay, is we realize, right, okay, that when things happen or when it is a humanitarian levels of disaster, be it an earthquake, a tsunami, a war, so on and so forth, it's very interesting, right, okay, that nowadays everybody, when they whip out their handphone itself, they will give you information that is actually very desirable. But likewise, you also create another situation whereby a lot of information are actually rubbish. Okay, so you have to have a way to kind of filter them too. But the point is, the data that we count on the few sources, okay, has changed. Okay, so we use it, right, okay, from anything from wildlife protection to Amazon rainforest situation, right, okay, deforestation, to really connecting, right, okay, internationally displaced person, right, IDPs, right, okay, in the case of migration patterns and so forth. So what we realize, right, okay, is really what has changed, especially in the last 10 years, is now everybody, every country in the world has got a mobile network and everybody uses mobile phone. So once you're able to use that, right, okay, in so many ways, from telco data to the image that they are picking up, to just who is tweeting something, right, okay, or passing a comment somewhere else, okay, on WhatsApp. When the mind is there, right, you can harvest those information and you'll form a situational picture that honestly 10 years ago could not have been done. Okay, so this is where we're exploiting this whole concept of crowdsource. Okay, and then from there, right, can really proliferate the idea of therefore get the response and the answers, right, okay, to the people who need it the most. Okay, that itself, right, as a trend and as a movement, right, okay, cannot be discounted. Okay, and henceforth, right, okay, the things you said about, I think it holds a lot of promise, right? Okay, once we know and really account for the changes that is going to facilitate some of this improvement that you are looking for, be it inter-coordination or the information sharing, so on and so forth. Yeah, thank you.
Maybe if I just react quickly, Giuseppe. Oh, sure. For me, goes a little bit, and thanks a lot, Kelvin, for that one. And for me, it's very promising. And the more kind of, I think what we are looking more and more also, I guess all the humanitarian organizations is more evidence-based as well. So having more data, putting into the table might help a lot. But for me, it's linked a little bit on how the whole sector might need to change. I said a bit, again, the question from the colleague from USAID who was asking, for humanitarian logistics, who are the customers? Are really the communities that we serve, the beneficiaries or the donors? Somehow, yeah, we have a lot of donor restriction because of the public funding that we receive. So what I feel as well is how to change this. On one hand, it will be on humanitarian organizations on itself. On the other one, it will be the governments. And I just put one example. Some organizations, we are tax exempted, so in order we get facilitation on the importation of customs, and I think Thomas has been mentioned before, but somehow also more and more the governments, and we have seen in Indonesia or in the Philippines, is not just kind of a free flow. Also, they have a list of needs, so they are trying also to control more the international assistance. So if traditionally we have been importing blankets, and suddenly through those new kind of ways of communicating with populations, suddenly the population feels that they need something completely different, but this information is not also kind of adjusted kind of and received by the host government, then we will lose all these kind of facilitations. And even if we need to kind of, the population is demanding something else, it might end up stuck in customs for a while. So I mean, it's just only raising a question into the air, and I think it's the proper forum here. I really like the opportunity the consortium and led by the NUS is leading and having the governments in here. So it's just only for the future design as well, some kind of questions in the air. For humanitarian organizations, I mean, we really need to work together with the governments and as well with expertise from the private sector in order to slowly and little by little move a little bit ahead and change the system slowly.
Yeah, if I may,
so just a comment.
Excellent points, and I also like some things of what you put in the chat about so capturing real time information, and using it. And I think some things that we mustn't forget there are two kinds of audiences here. One is humanitarian and one's non-humanitarian, but everybody's interested in humanitarian, and that's why we put it center stage. The things that we if you want to change the way things are happening, I mean, we're looking at the change through IT or through systems, not to change the humanitarian system. You know what I'm saying? Because that's where, like we said earlier, that's where your expertise comes in. Like my good friend from USA, Harlan, that's where, we always have those conversations. But when you're thinking about an IT system and then you look at it and saying, and I heard some interesting points, you can have a national IT system where this NGOs, if you like, or organizations can come in and it can be very national focused, very country focused. Yeah. So that's one approach. Yeah. Or you can take it down and say it can be organization focused. But when you take it to the level of ASEAN and say, let it now accommodate all of the needs of the countries as opposed to the organizations within the country. You know what I'm trying to say? Then the system must lose some functionality in order to meet the requirements of the wider audience, because it can no longer be customized to the particular country. Okay? But we mustn't forget that the system design is fractal in the sense that what we'll do for ASEAN, when ASEAN is multiple countries, if you think it in a country, it's multiple organizations and so on and so forth, right? So when we look at it from an IT perspective, and we had this in the end of June in our discussions, when we focus on the demand driven, it's all about who puts in the data. Yeah, do they have the system that interacts with other systems that would actually then be able to link up that data and to digest that data? Or do you want that data to be very localized towards a particular disaster at a particular time? You know what I'm saying? Because it's very important that we're not trying to change the humanitarian system, or we're trying to change it or transform it with IT, Because when you have the decision making in any industrial organization or commercial organization, then as Mary actually said earlier, and I love the things that came up in the chat, say how much does it cost? I mean, it's not a question that it's off the shelf and therefore I can just, take it off the shelf and just use it. Sometimes it might be if you meet all the constraints. But in my experience, when I shared the cost with some of the organizations, they never came back again, because the cost is not low. Let me put it that way. In respect of my industry friends, the cost is not low. The cost is fair. But if we all sort of get together to find out what is that functionality that we all require, and we can build it together. And we got some of the top organizations here committing their time and effort to make this happen. Then we can all get the advantage of that. Yeah, whether you're in government or you're in the humanitarian side or whatever you are, it's leveling up to the playing field. Okay? But you must be able to know what is it that you want. If you wanted to do all singing, all dancing functionality, then you should own it. Yeah. And I think that's what we came back to. If you actually, don't want to own it and don't want to maintain it, which is quite a significant enterprise in its own right, then there's some sacrifice that you need to make for the greater good. Yeah, what I mean? For the benefits. So I think these are the discussions that it's very interesting that you raise these points and all the audience is raising these points. But I want to move back to the first stage, and this is where we, SAS and Ethiopian actually put this conversation together. Is what do you actually require? How can we get those requirements that meet your requirements? Yeah. doesn't only meet 100% of your requirements, but it's a step in the right direction in meeting those requirements. If you get those requirements and you say, hey, this is what I would want out of the system, and if everybody else wants the same thing out of the system, then the cost is lower. Yeah. But if somebody wants it very customized to, I want this interface to look like this, and I want it to do this functionality, then it becomes very expensive to do that. And I also fear when I hear those questions, including in Singapore, and yes, I want the best system, but have you trained with the people in the use of such a system? Yeah. Have you actually taken them on the journey of what they can do? Yeah. And I think that this is quite key because we are coupling the two together within these workshops. And that's why I said one workshop like this is what can control towers do for me, and the other ones is how can they do it for me. And that's the workshop in August and 4 to 5. So we're always going to say, what is a digital twin? Well, what does it do? And then how can the digital twin work for me? Yeah. So it's always these two parts. But at the end of the day, we hope that all of you can not only share the good responses, the feedback, but all of you can actually share what is it, even if you have to take an evening, to write it, what do you want to see out of the control tower? We can address that tomorrow too. What do you want to see in the control tower? What must it do for you from what you heard from two really superb speakers? Yeah, and I know them both as very, very good friends. Yeah, what do you want to see? Now, you can just say, oh yes, I kind of like want to A, B, C, D. But what is it that you, as an organization, what requirements can you share with us that if we were to build this control tower, what should be in it? Yeah. And I'd ask you to do that. That's your homework for tonight. Yeah, because you give us, this speaker was superb. Yes, I know the speakers are superb because they are superb because we invite them because they are superb. Yeah. Okay. But if you can share with us in that section, say, a control tower functionality, if it can do A, B, C, D, or I can share with you the document of what I'm thinking about, that is superb. It helps us a great deal. So I hope, you all had a wonderful day ahead of you. Yeah, I mean, hope you all had a wonderful day that's just gone, and there's another wonderful day, and we're going to have Alvin back again tomorrow. His team, he has a lot of experience, and we're going to be looking at what can we do to build out this control tower. So you can influence it right now. Yeah. So now I'll open to you for any questions. Yeah. Any questions? Anybody want to say something? I think you got the messages of what we are trying to do with these workshops, and that's why they are kind of requirements, so gathering workshops, they are kind of with dissemination events, but all the speakers have been delving into a lot of the detail to share with you all that these things can do. But what should it do is what we're going to dive into next workshop, not the next workshop. So as I keep talking, I hope you at least have been completing the feedback forms. Any questions? Okay, we'll have a chance for you to think about things tonight and to share with us. So tomorrow, as we open up, we'll actually you'll be hearing from me, but I want to hear from you. What did you think about day one, and how can we move ahead? Yeah. I think we lost you. Okay, let me help him out a little bit while he comes back. So let me express that my thanks to all the speakers here. I think let me make sure that we don't. So, give me a second. So we had excellent speakers, and I'm especially not asking any questions from the last speaker because he is going to be speaking tomorrow, or his members of his team are, and he's certainly going to dig very much deeper in the next workshop on the 4th and 5th year. But I want to thank all of you for attending here. Please, I urge you to complete the feedback on all the sessions. This is very important for our grantor, whatever you might want to address it. Temasek Foundation has very generously supported these series of workshops. So I want to make sure that they get the right feedback. So, anything else we missed out? Are you back?
No, I think we're good, Bob. Thank you for summing up. Just to remind all our participants, the workshop will start at the same time tomorrow morning, which is 10 a.m. Singapore time. Do you have any more to add, Bob?
No, I've actually, because we want to reserve an IMO for tomorrow too.
Okay. In that case, thank you, everyone. Thanks for participating. It has been quite a long day, but you guys have been amazing. Thank you so much. We look forward to seeing you again tomorrow.
All right, thank you.
Thank you.
Okay, thank you.
Thank you.
Thank you. Thank you very much.
Bye.
Thank you. See you tomorrow.
Thank you very much.
Thank you. See you tomorrow.
Thank you very much.
See you tomorrow.
Thank you.
Recording stopped.
Eso sí.